technology solutions for pollutants and pathogens, resource efficiency, and help create products that benefit society through improved sanitation, promote livelihood, and economic development. Inviting Ms. Anuradha Shankar, CEO of TechLink, to give a brief introduction about TechLink, JSOE, and the Power Innovation Grand Challenge. Over to you. Good morning, everybody. As we move forward. So, as part of the Cochin, which is the Section 8 company of IIT Palakkad, and does all the incubation, we have 3 centers of excellence: the Global Sanitation Center of Excellence, which I will come to in detail; the MedTech Center of Excellence, which, as the name suggests, focuses on medical technology devices; and the Technology Innovation Center, which is the nerve center of the whole TechIn, and we conduct all the incubation programs as well as other incubations happen here. Example, those of intelligent collaborative systems are other sister concern, which is into safety and energy devices. So, for example, drones for safety in construction and AI, ML, those kind of things come under Technology Innovation Center. Now, coming back to GSCOE, as part of the incubation, we provide startup support in terms of innovation grants, state-of-the-art laboratory facilities for prototyping, as well as mentoring sessions, both in technical as well as business mentoring. We provide support for scale manufacturing and go-to-market strategy. The entire value chain, including marketing, financial, legal, whatever. The idea is to eliminate the chances of failure as we move along. So, so that's, again, I will not run through this, but to suffice that we have a board of directors as well as various advisory councils for each of the centers of excellence. Some of our incubatees include Pragati Tech, which is into disinfection robot. You will hear them in the afternoon today. We have Nirgan, which is into a toilet with biodigester and that saves on water, and there is no sludge, is there clean. We are rigorously testing it. They're also earning a little bit of revenue already. Ecovia, which is into disinfectant coating for toilet spaces, both the bowl as well as wash basin and everything, which will require less water for cleaning, as well as number of cleaning frequencies is lower. This is especially good for community toilets, and we have various other incubatees. We will go through it in the afternoon when we have a short video. MedTech also, we have some incubatees into elderly care, as well as AI Med, which is sensor-based integrated technology for ICU as well as home care patients who need to be monitored a lot. Then we have RoboBionics, which is into prosthetic arm with haptic sensory devices. And then we have drone for safety in construction, as well as some agri drone for fertilizers and a few other Sanitation Center of Excellence, where you can analyze everything from BOD, COD to nitrogen, phosphate, whatever chemical analysis you want to do before and after the product releases water. So as part of the GSCOE, we have various entities which are collaborating with us, and it was the brainchild of Professor Vijayaraghavan, as Swati mentioned in the preface. And we have international toilet board coalition and EM Scientific giving us the knowledge support. We have HDFC Parivartan and Bill and Melinda Gates Foundation, who are our funding partners, and we have various government agencies, both state and central, as well as NGOs, to support us in implementing and field testing all these items. The global sanitation center is to optimize technology and scale it both from the technology perspective as well as the business perspective. And so we have the full value chain, which consists of 4 pillars. The first pillar is to funnel the technology into the incubator. The second pillar is to provide all the support that the incubated team needs, from business technical mentoring, as I mentioned earlier, prototyping, testing, which is really important, and it starts at this phase itself. Not just lab testing, but field testing to make sure that the device works in each and every setup. So what works in Alapura, high water table of Alapura, will not work in Rajasthan, which is dry, or will not work in Kotagiri, which is hilly location. So it has to be fine-tuned for each and every different kind of environments. Pillar 3 is to help them scale manufacture. The prototype that you've made in the lab will not work in the field, or will not be capable of being manufactured in large volumes, and therefore you have to redesign the whole product. We provide support for that, and then as well as business and showcase of this across the country for incorporating them into proper stuff. The 4th pillar is to train and test and certify these products are meeting the standards that are required. So there are a lot of standards, both globally and in India, which need to conform to, so that we don't pollute the environment, we don't create harm and hazard for the sanitation workers who are going, very often not supposed to be going down the sewer lines, but they are, maybe as contract laborers or whatever. So we have to make it safe for them. Also, we have to reduce the amount of pathogen overload which can affect us in the long term. The other important point about pillar 4 is that we provide training of the maintenance and service personnel, which is really essential. For example, take a city like Bangalore, a lot of STP plants were set up. STP is sewage treatment plant, for those of you who are not aware with the abbreviations. But 20 days later, many of them stopped functioning because there's nobody to maintain service. And the other challenge, of course, is awareness of the public in using these. So you can't be putting sanitary pads or random plastic objects into the toilet bowl and assume that it'll get flushed in, but it happens to clog the STP. As I mentioned, we have various NGOs, including Keystone Foundation, DICCI, S3IDF, and a whole lot of state and central government agencies to help us. And some of the themes, there is a lot of circular economy that can be generated from this, including recycled water, nutrients like nitrogen and phosphate. Probably Dr. Prabhaav in the talk will talk about how they are recovering some of the nutrients, as well as they're trying to generate some energy out of the system. And this is our MedTech center. We have West Pharmaceuticals collaborating with us for that, and some of our partner institutions, and our family consists of IIT alumni, as well as people who have roots in the Palakkad, Coimbatore region to start with, but we have people all across the country who mentor and help support these startups. All our startups are all across the country. It is not restricted to students, faculty and staff of IIT Palakkad. That's a point too. Coming to the training, we already have the first batch that has started, and they've completed 150 hours of 80% practical, 20% theory, and they've become plumbing apprentice, and they are now undergoing internship in a factory in Coimbatore. I will not go into details of that. And then coming to the grand challenge, this you would have already seen in the mailers that have gone out to you. So the grand challenge is started in January. It will go on till May when the final pitch takes place on the 13th. The applications close 11th of March, and the idea is you take any of the theme statements. There are a whole list of statements that are put there in the website as well. You can go through them. You can take any one or combination of two or more and work on those, come up with the idea, and we have one team that is going to pitch in the afternoon as well. There will be a mentoring and a pitch round initially in March and early April, after which you will get a small funding of 50,000 rupees to do the, selected teams will get 50,000 rupees to do the initial prototype and come back to us for the second round of mentoring and final pitch on May 13th. Once you are selected after the final pitch, you get incubated, and you can come to IIT Palakkad for the prototyping and testing. Otherwise, you can be anywhere in the country and do the mentoring sessions online. So we've had 3 online sessions. 28th of January we started with Dr. Mohanty from PSA's office, that is Principal Scientific Advisor to Government of India. This was our Coimbatore event. Then we had the online event again on 11th of February. Bangalore event, 21st of February we had another online event with people from Indian Sanitation Coalition, Urban Management and so on. The idea is to bring people from government, from NGOs, from industry, from plumbing associations, from every gamut and academia to support this drive to make a change. So I will stop with that. Over to you, Swati. This is the Coimbatore event.
Thank you, ma'am. It's my pleasure to introduce Sri Venkatesh Padhyay, SIAS, as our chief guest and keynote speaker. Sri S. Venkatesh Padhyay is presently the Managing Director of Kerala Water Authority. He is 2009 batch IAS officer of the Kerala cadre. He had earlier served as the Secretary of the Thiruvananthapuram Corporation and later as the Managing Director of the Civil Supplies Corporation. He started his career as an assistant collector in Kozhikode district and later served as a sub-collector in Idukki, Devikulam and Kasaragod. He was also the district collector of Malappuram and Thiruvananthapuram districts. It's a pleasure to have you here with us, sir. Invite you to deliver the keynote address.
Thank you very much. I hope I am audible.
Yes, sir.
Am I audible?
Yes, sir, you are audible. Sir, you are audible.
Oh, thank you. So, let me first of all apologize for not being there physically to attend the meeting. However, I find find it very exciting that IIT Palakkad has been having a series of conferences, methodologies. The think tank wants to implement in a different manner. So I should first thank you. As well as the participants, the taking group, IIT Palakkad, GSCOE. So let me directly go into the concept of liquid waste management. Now we all know that liquid waste management is a huge subject. Basically, it is to prevent the pollutants or the hazardous stuff entering into the water bodies and into the environment, leading to harmful outcomes. So there are several methods available. One of the methods is basically sedimentation, dewatering, and solidification, which is basically removing the solid particles and then taking out the water. That is one part. The second part is we have moved forward in such a manner that our urban sector has outgrown beyond our expectations. With that, the challenges of liquid waste management has tremendously increased. With that in place, not only one technology, but a series of technologies, adaptations, depending on the ground structure is necessary. As of now, the Kerala Water Authority is moving into that particular field also. So it is nice to know that the think tank is ready and challenging and incubates several parties who can come in with a business and then do good cooperation. So what we have done is, I just a small plan. Right now, we have 10% for active research. What happens is, patients and such entrepreneurs. So that's the main idea behind it. Now we have to move towards zero liquid discharge. That should be our idea. In colleges, in institutions, in bigger government institutions or offices, we need to inculcate the habit of having zero liquid discharge. That's the most important thing. We are floundering in that particular aspect. So it is not only putting up plants, the STPs, the FSTPs, or smaller levels of infiltration structures. It is to showcase that it is possible and global in offices, government institutions, colleges also. I had a recent visit. I was not aware. I must be aware of several technologies. I wasn't aware. We went and saw Jakusa model in Mumbai. It's a very small prefabricated structure. Approximately 10 to 15 KLD of sewerage is treated. And this occupies like 10 feet by 10 feet, that's all. And sometimes it goes underground also. Now this particular aspect cost us maybe 15 lakhs or 16 lakhs. An institution like Kerala Water Authority will be readily accepting the technology and willing to do it in one of the institutions or in some of the slum areas that are available in the cities. So the technological incubation that we are trying to bring in should coincide with the practices, the funds that are available with the government institutions, as well as the projects of Government of India also. The ideas should coincide with the funding pattern and the methodology that has been adapted by governments. So I believe that we will be able to do good. The STPs has been playing a major role in terms of liquid waste management, the sewerage management basically. And we can see that the industries go for this recycling also. As far as I am concerned, the orientation has to change. When we go to a foreign country, the top-up provided through the sewerage filtered drinking water is to the tune of 20 to 30%. but it is not accepted in India. The framework has to change. For that, the think tank has to say that not only primary, secondary and tertiary, we should go for ultrafiltration also. Thereby, we supply back this water to the drinking purpose also. Thereby, the demand on the existing water resources can be reduced. You go to Singapore, it's 30-40%. You go to Europe, you directly drink from the taps, public taps, anywhere. The quality is maintained in such a manner and the water is recycled. So, my request to the think tank, to the institutions and the entrepreneurs who have been here, kindly look into those aspects also. Sujita Mission has been playing a greater role in bringing this particular think tank into the government setup. So, I believe that you will be able to do good work. Put us with the challenges, put us with the solutions so that the government can adapt, pilot, implement and upscale it. With this, I close my words. Thank you for giving me such an opportunity. All the very best for the institution. Thank you. Thank you.
Thank you, Dr. S. Venkatesapati, IAS, for the inputs and condensing your experience in a wonderful way and giving us an inspiring talk. Thank you, sir. Next, our plenary speaker for today is Dr. Praveena Gangadharan. Dr. Praveena Gangadharan is Assistant Professor, Department of Civil Engineering at Indian Institute of Technology, Palakkad. She completed her BTech and MTech from College of Engineering, Trivandrum, and PhD in Environmental Engineering from IIT Madras. Her teaching and research interest includes bioelectrochemical systems for wastewater treatment, desalination, defluoridation, nutrient recovery from urine, metal reduction and recovery. She has served as assistant professor at MG University, woman scientist sponsored by Department of Science and Technology, Indian Institute of Technology, Madras, associate professor at APJ Abdul Kalam Technical University. She has won many awards including several Best Poster Awards, Early Career Research Award, Best Paper Award, Gandhian Young Technological Innovation Award and many more. It's a pleasure to have you here with us, ma'am. Welcome.
Good morning to all. I'm going to talk about innovative, I'm going to talk about innovative approaches and technologies for decentralized liquid waste management. So when we look into domestic area, so you can see that there are a lot of activities, and because of a lot of activities, wastewater will be generated, and this wastewater can be classified into two types. One is a grey water and another one is a black water. Okay, and the grey water that is generated from various household activities like washing, cleaning, cooking, etc. Whereas in the case of black water, that is generated predominantly from toilet bowls, which consist of urine and feces. Now, these two wastewater currently mix together and then it is just disposed into a public sewers. So if we look into the characteristics of this wastewater, you can find that various constituencies are there in the wastewater, and depending upon the concentrations, we can classify it into three types: weak, medium and strong. So to make it more understandable form, I can show you that the wastewater, the constituencies and their environmental significance. So if we see that the wastewater has suspended solids, and if you don't remove it, it can cause sludge deposits and anaerobic conditions in the aquatic environment. So if the wastewater has biodegradable organics, then it can cause biological degradations, and which may use up oxygen in receiving water, and that will cause undesirable conditions. Now, the wastewater has pathogens, so that can transmit diseases, and then it can also has nutrients, so that can lead to the cause of eutrophications, basically excessive growth of algae, and the wastewater has dissolved solids, so that will cause or that will interfere the effluent reuse. So we need to treat this wastewater. We cannot simply dispose into the environment because it can cause a lot of undesirable situations in the environment, right? So now if you look into the treatment systems, so this is a conventional treatment systems have three stages. As you can see that primary treatment system, secondary and tertiary. So primary treatment system is intended to remove large objects like plastics or wooden subjects, or there are many other eggshells, etc. So their density will be very, very high. So we generally given screens or grid chambers in the primary system, and it can able to remove 60% of solids and BOD 35%. Now we have to go for secondary treatment systems where we can remove dissolved solids. Okay. Now we take the help of microorganisms in this case, because microorganisms are powerful to degrade the pollutants, and this is a natural mechanism because they consume the organic matter as food. Okay, so we can treat most of the organic matter in the treatment in the secondary treatment systems, and 85% of BOD can be removed in the system. But the secondary treatment system cannot remove 100%, as you can see that 85%. So we have to go for tertiary treatment systems, and in tertiary treatment system we can remove 95% plus BOD. We can remove pollutants like nitrogen and phosphorus, and we can also remove pathogens. Okay, now this is the conventional treatment systems, but when you look into this conventional treatment systems, they have their own inherent limitations. Okay, so what are the inherent limitations associated with this conventional treatment systems? So if you look into that, the conventional treatment systems are designed to remove the pollutants, okay, and make it suitable for or to meet the drinking water standards, as you can see here. And there are many valuable substances in the wastewater like nitrogen, phosphorus, etc. then that cannot be recovered in this scenario. And if you look into the wastewater, there are technologies like activated sludge process. We have to continuously aerate them, and then that will demand certain energy in the conventional treatment systems, and its operation and maintenance cost will be very, very high. Now, considering these all limitations, we have to think about an alternative approach to minimize the existing limitations posed by the conventional treatment systems. So if you look into that, I'm going to introduce a new approach. Okay, so that approach is called segregated streams or ecological sanitation approach. We can see that EcoSan. So here, wastewater we can see as resource. Okay, so here the wastewater can be classified or can be categorized as three, like grey water, yellow water and brown water. So yellow water is predominantly urine and brown water is predominantly feces. So if you see the grey water, okay, So the major component of the grey water is water. Now it has 75% of volume with organic matter. The predominant constituencies in the grey water is organic matter, and the nutrients are very less with the low pathogens load. So if you supply or if we give a minimum level of treatment, we can recover this grey water and we can reuse it for various purposes, like recycling for flushing and irrigations. And one of the research that we have carried out using grey water for construction activities, and probably Sunita has taken up that work, and she can give more insights on that area. And the next one is yellow water, predominantly urine, and you can see that in yellow water the composition is more nutrients. It has nitrogen, phosphorus and potassium when compared to organic matter, but their quantity or contribution is only 1%, although their quantity is very less. So what would happen is, normally in the conventional treatment systems, this urine is getting mixed with the grey water. What would happen? Because of the dilution, dilution will take place, and because of that dilution, we are unable to recover nutrients present in the urine. Okay, so although its contribution is very less, but we can concentrate it, we can divert it, we can concentrate it, and we can use it directly for fertilizer. We can use it as either liquid fertilizer, or probably we can use it as solid fertilizer. Now next is brown water. So brown water has very less quantity. The volume is 0.1%, and organic matter is very high, and phosphorus content is also very high. So we can use it for either biogas or compost, and can be used as a fertilizer. So this is the segregated streams or eco-sand approach. Now, if you look into what is the positive impact of segregating this wastewater in a large perspective. So to understand that scenario, we have to see the other side of the coin. So if you look into the global scenario, okay, so you look into the global scenario, you can see that by 2050, the world population will be 9 billion, and in order to feed these people, we have to increase agriculture production. So when you increase agriculture production, we have to, in proportion to that, we have to increase water as well as energy production. So these are the reports given by United Nations. Now when you increase agriculture productions, we need to increase the fertilizer production as well. So the annual demand for fertilizer increases by 3 to 4% each year. And according to the data given by Fertilizer and Agricultural Organizations of Food and Agricultural Organizations of United Nations, you can see that there is a large discrepancy between the demand of fertilizer and its supply. Okay, so if you look into that, there is a huge quantity of fertilizer is required. However, its availability in the earth is very minimum. So in addition to that, if you see that this case is, we can apply in the case of metals. There is a huge quantity of metals are required for various activities. For instance, it can be applied for transportations, communications, etc. But there are demand in the earth is the supply in the earth is very less. So on the other hand, we can see that these components are there in the wastewater. So if we can come up with a strategy to recover these resources, we can actually connect the dots and we can achieve sustainable goals. Okay, so that is the idea. So with that, I would like to introduce certain technologies that I'm currently working on, and here I'm predominantly focusing on developing energy positive treatment methods to achieve resource recovery from wastewater. And these are some of the technologies. We will look into that in detail. The first one is microbial fuel cells to recover metals from wastewater. So this is, when we look into microbial fuel cells or that technology, first we need to know the heavy metals. So heavy metals are widely used for various applications, and these are widely used in various industries like metal plating, mining operations, etc. And among these heavy metals, you can see that chromium and copper are widely used as an oxidizing agent in various industries like pharmaceutical, wood, electroplating, leather tanning, etc., because they can improve the resistance of metals against corrosion, impact, and oxidation. Since chromium and copper are widely used in various industries, the discharge to the environment has gradually increased, and it's very important that because of their tendency, it's very important that they are very toxic and they have a tendency to accumulate in the living organisms. Now, acute exposure of these pollutants can lead to various diseases like this, and in India, these are the places where chromium pollution is happening, and these are the places where copper pollution is happening. The four stringent standard has been given in order to regulate these pollutants. In the case of chromium, it is 0.1 and copper, it is 3 milligram per liter. Now let us look into that, how we have recovered chromium with the help of microbial fuel cell. So here, the strategy that I have adopted is utilizing wastewater to treat another wastewater. So here I have utilized domestic wastewater to treat metal bearing wastewater and recover its resources. So if you look into this case, this is a microbial fuel cell. You can see that two chambers here, one is an anode chamber and cathode chamber. Now we placed domestic wastewater in the anode chamber. It has a lot of microorganisms, and there is a metal bearing wastewater in the cathode chamber. So these two wastewaters are separated by a proton exchange membrane. Now we have chosen this wastewater based upon the redox potential because the organic matter can easily undergo oxidations, whereas this metal bearing wastewater can undergo reduction. So what would happen is, because of this oxidation reduction reactions, the electrons that is generated from this anode chamber can travel into the cathode chamber, and this chromium 6 plus is readily, in a high valence state. It will accept the electrons and it can convert it into chromium 3 plus non-toxic form. This can be applied similar to the copper. Copper can readily accept, copper 2 plus can accept, and it can convert it into copper. So what would happen is, finally we can achieve domestic wastewater in the anode chamber, metal bearing or metal reduction recovery can achieve in the cathode chamber, and we can achieve energy recovery as well. So one of the important component of microbial fuel cell is electrode. So this is the electrode, and we generally use carbonaceous electrode material for microbial fuel cell. Now these are the recovered chromium that you can see. Chromium can be recovered as chromium oxide, and metals, copper is deposited as copper on the surface of the platinum electrode here. Now, as I said, we use electrodes in the microbial fuel cell because it's an integral part of microbial fuel cell. But one of the inventions that we have carried out in my lab is to use, disposed LCD panel as an electrode material, because we found that this disposed LCD panel has a lot of functional groups, and also it has electrode hair problem and the skin. Now another constituency, another pollutant is fluoride. So fluoride is actually in low concentration it is beneficial to our body because it can prevent dental decay, whereas in the case of high concentrations it can lead to fluorosis, skeletal fluorosis as well as dental fluorosis. So the standards are the acceptable limit is 1 milligram per liter, permissible limit is 1.5 milligram per liter. So we don't actually remove the pollutants entirely because some concentration is required. In case of hardness, the calcium and magnesium, some minerals and fluoride is required for our body. So we don't need to remove it completely. So what we have done was, most of the treatments, they will remove it completely. So we have come up with a technology called forward osmosis. It's actually the reverse of reverse osmosis. So in reverse osmosis, we have to apply a lot of pressure, but in this case, we don't need to apply pressure, it's just a natural process. So here what would happen is the two liquids are separated by a semi-permeable membrane. Okay. Now the water is always moved from high water potential to low water potential. As a result, there is a concentration of water will be taking place in the feed solutions, whereas flow solution is getting diluted. Okay, so basically what would happen is we have two solutions. One is a plain water and another one is a saline water, and which is separated by a forward osmosis membrane. Then always water moves from plain water to saline water. Okay. Now this technology has various advantages like high quality water extraction, a dilution of highly saline streams, whereas it has demerits like incompetent in degrading the contaminants. The organic waste rich in energy content cannot be recovered during this process. So now what we have done is we have integrated these two technologies. One is a forward osmosis process with microbial fuel cell. Now why we have integrated means when these technologies, when they stand alone, they will exhibit inherent limitations. However, when we integrate it together, these two technologies complement each other and can exhibit the advantages of both technologies. Now, so in the anode, so basically this is two compartments, anode and cathode. So we place forward osmosis membrane in between. Now these are the two electrodes. The wastewater is placed in the anode chamber, and due to the microbial activity, energy production will be taking place. And in the cathode chamber, we place the groundwater. Now what would happen is, if you look into this case, the wastewater, in this chamber we have placed the wastewater, and in this chamber we have placed the groundwater with the hardness as well as fluoride. Now what would happen is there is a concentration gradient will happen in between these two wastewater. So water will be moving from the wastewater into the groundwater. As a result, this wastewater will be getting concentrated, whereas in the case of groundwater, which will be getting diluted. So we can achieve water flex of 9.81 LMH with the reduction efficiencies of various pollutants in the groundwater, and this can also achieve wastewater treatment because COD removal efficiencies of 87.6% with current density of 0.34 milliampere per meter cube were achieved in this process. So this work we have published in Journal of Environmental Engineering recently. Now next is we have developed another technology, we call it as microbial desalination cell to achieve desalination, defluoridation and all these things. If you look into the microbial desalination cell, these are again the modified form of a microbial fuel cell. Here anode and cathode chamber is separated by a middle chamber, and this is called a desalination chamber where we can desalinate. The desalination chamber we will place saline water which consists of sodium and chloride. Now what would happen is here the wastewater is placed in the anode chamber, the aerated water is placed in the cathode chamber. So the saline water, basically what would happen is that wastewater in microorganisms, oxidation of the organic matter will be taking place, and there is a excess quantity of protons will be generated in the anode chamber. So in order to minimize that, chloride will be moved from middle chamber to the anode chamber through the anion exchange membrane, whereas in the case of cation exchange membrane, the sodium will be moved from middle chamber to the cathode chamber. So this is the working principle of the microbial desalinations. So this technology we have applied not only for saline reductions, but also we have applied for fluoride defluoridations as well as softening. So we found that the performance of the microbial desalination cell is purely depending upon the initial concentration of the pollutant. Now these are some of the recognitions because it's my research scholars are working on, and some of the recognitions received as part of this work. Now next is resource recovery from urine using bioelectrochemical systems. Now coming to the urine part, so basically we have looked into the ecosan approach. We are segregating the urine. Now why we need to recover resources from urine? So if you look into the urine has 95%, 93 to 96% of water, and remaining they have a macro as well as micro elements, as you can see here. And the composition of the urine will be varying with respect to the personal diet. Now, a person can produce 1.5 liters of urine every day, and that urine consists of 11 gram of nitrogen, 1 gram of phosphorus, and 2.6 gram of potassium. Now, this is just discharged into the septic tank, and once it is filled, it will be taken and then disposed into the environment scientifically or scientifically, or it can be currently it can be just discharged into wastewater treatment plant. And you know that when we dispose it into the wastewater treatment plant, basically the dilution will be taking place and its recovery is complicated. So even in the after treatment, wastewater treatment, if the plant is not working well, then it can discharge into the water body and can lead to eutrophication. So we have to recover these resources from the urine, and now because it can play a pivotal role in the water, energy and food nexus. So if you see that the water part of the urine, the global production of urine is estimated to be range of 1.16 into 1.54 10 raised to 10 liters per day for a world population of 7.7 billion people. So if you recover this water, we can just apply it to the deprived communities where water scarcity is more. And the fertilizer part, if you concentrate the nutrients from the urine, we can directly use it as either liquid fertilizer or solid fertilizer. And urine is an excellent fuel for electricity generation, so we can produce electricity from urine. Now, how to tap this resource? So we can tap the resource by separating urine at the source. And how to separate urine at the source? So we can use urine diverted toilets. So urine diverted toilet has two components, front side as well as back side. So front side it can collect urine, and the back side it can collect feces. So these are some of the commercially available urine diverted toilets available in Sweden. And so when we looked into the electricity production of urine, so there are a couple of studies already done, and this is the study done by the Bristol University. So here they have used urine and they started generating electricity from urine. So this is a urine powered urinals installed in the campus of University of the West of England in UK, and they call it as P-Power. So prototype was aimed to light urinals in refugee camps. Now after successful demonstrations, they have placed it in a pilot scale mode in a field trial in Glastonbury Music Festival, England in 2015. The system was expanded to include 10 people at a time. The total capacity was 330 liters and was able to light 6 LED modules. So after successful demonstrations, they have installed in the remote areas of developing countries. So this work actually motivated us to focus in the direction of urine. However, they have only focused on electricity generations. So there are many resources in the urine like water and nutrients. So we thought of focusing in that direction. So we have developed an osmotic urine fuel cell for water, energy and nutrient recovery from urine. So this is actually again the integration of forward osmosis with microbial fuel cell. So in this case we can see that the anode chamber is urine and the cathode chamber is brine solution. So now what would happen is the urine, oxidation of the urea will be taking place and that can generate electrons, and in the cathode chamber there is a brine solution, and also there is a forward osmosis membrane, so that can transmit water from urine to the brine solution. The entire process can achieve electricity. So if you see here, what would happen is the urine is getting concentrated because the water from the urine is flow from anode chamber to cathode chamber, and the brine solution is getting diluted. So this concentrated, because forward osmosis have high rejection rate for TOC, TN, ammonia and phosphate, so we can directly use it as a fertilizer. And in the cathode chamber, since there is a dilution is happening, so brine solution is getting diluted and some reduction in the salinity, 25 to 32% is taking place in the cathode chamber. So this is the experimental setup, and this work was published in these two journals recently. Now we have started developing an electrochemical phosphate recovery because, as I said, it is very important to recover nutrients from the urine and also the electricity. So but why solid fertilizer is important? So in this case, we are talking about the struvite. So as you know that, this urine has ammonia as well as phosphate is very high, but what it is not the magnesium. So if we supply magnesium, we can get struvite. And this is a slow fertilizer, struvite is a slow fertilizer. So this is a schematic view of electrochemical phosphate recovery reactor. Here the magnesium is acts as an anode, so magnesium will undergo oxidations and give magnesium 2+, and at the same time it can also produce electrons. So this is an energy positive treatment system. So we need to start it from somewhere. So this is actually because there are not many literatures available, so we thought to start with a small systems. So this is a schematic view of the reactor. So we have started with a 250 ml volume, and this is the pictorial view of this reactor. And then this is we need to fabricate the gas diffusion electrode that is acting as a cathode, and we have to check the quality of this gas diffusion electrode. So we have performed certain experiments and then we applied it in the system. So now we produce fertilizer like this. So this is a fertilizer that we received from that reactor, and the quality of the struvite we have checked, and we found that the quality of the struvite is good, and also we found that this small cell can produce a voltage of 1, and also when we connected series, so we found that this is a small video. So when we connected series, and we found that the system can produce around 3.48 voltage. So this is 8 cells we have connected it. So this can be able to produce around 3.5 volt, 5 voltage. So now the batch study was completed. Now we are looking for the continuous reactors, as you can see in this picture. Now once the continuous reactor is successful, then we will scale it up, and this is the pictorial view of the scale-up version of the reactor. Now we have a technological solutions, but we need to implement this. So we can implement it in the ecological sanitation toilet systems. As you can see here, this has 2 compartments. As I said, in the front compartment urine can collected, so urine will be collected. In the back compartment, feces will be collected. So this is not new actually. This kind of a system is already practiced and also implemented it in South Africa, and in India also it is implemented, but I am not very sure about the performance of the system because I have got this information about this website. So, and there are many innovative designs available, and these are some of the innovative designs. The toilet designs are available. Now to conclude, so basically the conventional treatment systems need to be upgraded. As already mentioned that they are intended to remove the pollutants, and we have to go for a resource-oriented approach. That means eco-san approach, where we see the wastewater as a resource and we can recover maximum resources from the wastewater. Now segregating wastewater at the source provides various opportunities like recover water, energy and nutrients from the wastewater. It can also minimize the treatment cost by reducing the pollutant load to the sewage treatment plant. And we have, so the whatever technologies that I have shown to you is in the infancy stage, that means in the laboratory stage. So there are more research is required to materialize these technologies. And at the same time, we need a support of various stakeholders, because this is a collective, we need to support from various stakeholders like, from NGOs, from funding agencies, because more researchers need to be given in this direction. And at the same time, the community perspective is also very important, because whatever the technology we developed, and when the community is reluctant to use it, then there is no point of developing those technologies. So what is the demand of a community? And at the same time, we have to make them aware that the importance of recovering the resources. So nowadays we are just simply letting it off all the wastewater, treat it and then remove the pollutants. But we need to somehow recover these resources and back to the community, and we have to close the loop. So with this small information, I would like to conclude my presentation. Thank you very much, and these are my team. Thank you.
Thank you, Dr. Praveena, for the very informative session and giving prospective entrepreneurs in the field an insight into the vast opportunities in the sanitation domain. I would like to invite Mr. Ramachandran Pullar to give the memento to Dr. Praveena. Thank you, sir. Thank you, ma'am. We can have a short tea break of 5 minutes while we set up the stage for the next panel discussion. Thank you. We would like to start with our first panel discussion for the day. Our panelists are Mr. Ramachandran Pullat, Mr. Bijo K. John and Mr. Zakaria Joy. Our panel will be discussing on sewage management. Our first panel member is Mr. Ramachandran Pullat. He is the founder managing director of Geotech Services Private Limited. He is a renowned innovation thinker and expert in plumbing and civil engineering businesses. He is a civil engineer with 40 years of experience in the field of construction who has begun his career with L&T ECC Construction Group. Since 1991, he has been in the field of plumbing. After 12 years stint with S&Co, he started his own company called Geotech Geotech Services Private Limited in 2003. He has executed numerous plumbing and firefighting installations throughout South India. He is a lifetime member of Indian Plumbing Association and a member of IPA's National Executive Committee, Constituent Technical Committees, and has been actively involved in creation of IPA codes and reference books like Uniform Illustrated Plumbing Code India, Green Plumbing Supplement India, Uniform Swimming Code India, etc. It's a pleasure to welcome you, sir. Our next panelist is Mr. Bijo K. John. Mr. Bijo is the Managing Director and founder of Tritech Engineering, specialized in building information model solutions, combined with customized MEP solutions and service designs. He has over 30 years of experience in the field of engineering design and consultancy and is a certified professional in Autodesk Revit architecture. He is also the director of Tritech Design Academy, a finishing school for engineers that provides upskilling programs for civil, mechanical and electrical engineers. Mr. Bijo is a graduate in engineering and a member of several national and international professional bodies, including Autodesk Developer Network, member of India BIM Association, ISHRAE and IPA. It's a delight to welcome you, sir. And next in the panel we have Mr. Zakaria Joy. He is the founder and CEO of Northam's EMB Solutions, a knowledge exchange center and waste management company working in the waste management sector, focusing on high-rise apartments throughout Kerala and a service provider for Sujata Mission. Through his venture, Mr. Zakaria acts as a consultant for formulating guidelines for integrated wastewater and septic management for Kerala State. He works with CREDI, Clean City Movement, and also provides technical support in waste management for 20 local bodies of South India. Through the Knowledge Center of Northam CND Solutions, Mr. Zakaria is envisaging to provide short-term upskilling courses and R&D programs in waste management and water pollution abatement. A very welcome to you, sir. The panel will be moderated by Dr. Sunita K. Nair, Assistant Professor, IIT Palakkad, requesting the panelists and Dr. Sunita to come up on the stage. Thank you.
Thank you for introducing the panel members. A warm welcome to all of you. I think in the onset, we should just think of why we are talking about sewage management, because though it's part of sanitation, it is also one of the most important part of the sustainability development goals. If you see, the SDG 6 is directly related to access to clean water and sanitation, and there are other SDGs also which are indirectly related to sewage management. So I think for any country to move forward towards the SDG, sewage management is going to be very critical, and in this direction we will be having some discussions today with the August panel members that have assembled here. We have been able to bring them here to one platform. And as we know, sewage treatments, the goal of sewage treatment is to bring the effluent to a standard where we can dispose it off safely. There are very critical components like nitrogen, total nitrogen, phosphorus, etc., which are quite difficult to handle, but still there are techniques. Now, problem is not we don't lack technology in these treatments. What we need is technology innovations because there are many challenges that are coming up with the growth in urban population. I think all of you will agree that we have challenges like space constraint, time constraint, the retention time has to be reduced, awareness of the importance of sewage treatment, and many manifold problems that we are facing. So I hope that this discussion will be revealing some of the major problems as well as solutions, and it's appropriate that we have a right combination of specialists here. We have Mr. Ramchandran Pullat. He has a vast experience in implementing plumbing systems and also in standardization. I think that is something that's to be really put forward. And we have Mr. Jijo John, who has a lot of experience in designing systems, treatment systems, plumbing systems. And we also have with us Mr. Zakaria, who could be considered as one of the young entrepreneurs in this area. And we will get to hear from them. So let's move on. Shall we move on? So my first question is to Mr. Ramchandran Pullat. What do you think is the role of plumbing in increasing the efficiency of sewage treatment systems?
Thank you, Dr. Sunita. I think one of the goals of this conference, the conferences we are having across South India, is to throw up ideas where young entrepreneurs can pick on them and then develop some systems which can be used in managing sewage and stuff like that. Now, at the outset, let me tell you, though I have been in plumbing or construction for almost 40 years and 30 years in plumbing, my domain expertise is not in sewage treatment. That's one aspect of plumbing. My expertise has always been on the installation of plumbing systems. And I think that is where this is important, that you've got somebody like me. I'm not saying I'm the right person, but somebody like me, because I see your slogan is innovation, synergy, and catalyst, right? Unless you have somebody from the plumbing industry also as part of the whole thing, you won't get a proper solution. Let me give you a simple example. I was listening to Dr. Praveena's very interesting talk on how we need to take nutrients from urine. Okay, straight away, we are all Malayalis. Most of us are Malayalis, and the first thing we want to say is no, it's not possible. So let me be a true Malayali and tell you that is going to be a bit of a problem, because you're going to increase plumbing costs by almost 30%. Because you need to have separate systems for urine collection. You need to have separate, your bathrooms become bigger. This is something which, if you discuss with us, maybe we can tell you that this is something which can be introduced in factories or in offices, where most of the effluent which is coming out will be urine. You understand what I'm saying? So we need to figure out where this is going to work. And the other thing which I want to tell you is that, a sewage treatment plant does not succeed in most cases. You can correct me if I'm wrong, Zakaria, is that, first of all, in the initial days, nature took care of our effluent, right? There was no sewage treatment plant. But now there is a concentration of people. There's a concentration of water coming out at a particular place. So that needs to be treated. So in such a case, it is essential to have a sewage treatment plant which will work, which is basically what? Converting it into water and carbon dioxide or various forms of carbon, isn't it? And sludge is the other. So the treatment is critical. But what really goes wrong in treatment is the fact that the amount of water which we are using is enormous. Enormous amount of water. The National Building Code tells you that you need to use 135 liters of water. It just gives you a guideline, 135 liters. You take a flat in Cochin, with 4 people staying, it's 1,000 liters of water which comes out. So the load is enormous. We use so many detergents, we use so many moisturizers, we use so many chemicals that it doesn't matter what level of sophistication the STP is, you are bound to have a problem if it is not maintained properly. The third problem, there are others to speak, so I'll just stop with saying that the third problem that we've got is, Kerala is a state where, I'm sorry to say, the state has abdicated its responsibility. The state does not provide you really good clean water, as much as we need in all the places that we need. So we produce our own water. Secondly, the state does not have any real underground sewage system to take care of the sewage which is generated within apartments and hotels and hospitals. So now what happens? Every individual, every apartment, now for example, this hotel is an institution where I did the plumbing. We've got a sewage treatment plant over here. Similarly, apartment blocks you do, hospitals you do. The state insists that you have to put your own sewage treatment plant. Great. Ask not what the state can do for you, ask what you can do for the state. It's all great philosophy. But who checks what happens in the sewage treatment plant? Nobody checks. Nobody checks. So, end of the day, what you're doing is basically creating multiple centers of possible epidemics in the future. Immediately, the first thing which, Zakaria, Biju, you can correct me if I'm wrong, the first thing which gets shut down as far as sewage treatment is concerned is the blower, because it takes so much of electricity. So we need to look at that. That's one of the problems. How can we reduce all these things? I think today we had a talk by the MD of Water Authority. Is if the government can get involved in instituting measures for reducing water consumption. Not have these huge, rainwater showers which spew out water at 80 liters per minute. So you stand under it, it is 800 liters of water per minute. And that's the amount of load which comes into the STP. Do they know what is happening? Does the plumbing engineer inform them that there is this much of problem is there? So the point I'm trying to make, very large point I'm trying to make, is that there has to be a synergy between the people who are developing these systems and the actual installers of the system. If that synergy, if that confluence is not there, you will be innovating in isolation. And this sort of backward integration, in my opinion, is very important. As we go, we can possibly talk about specifics, but...
Thank you, Mr. Ramchandran. I think we've got the point that you're trying to raise, and I think it's very important that awareness about the issues will give some solution, so that is the first step to solution, I guess. So I think Northams has been developing some solutions. So would you like to share with us some of the innovative solutions that you have come up with in the recent years?
Good morning all panelists and moderator. Basically, we didn't develop a new technology or innovate anything. We follow the practices or the technologies already available on the market. I do agree with what Mr. Ravindran says. Basically, technology is there. Technology is not a failure as per our experience. The main thing is, if you take an example of a sewage treatment plant, there is basically 3 stages: primary stage, secondary stage, and tertiary stage. So we know the secondary stage is the core technology. It is working very well if the primary stage is okay. If the primary stage is okay, the plumbing system should be okay. In our experience, a big brand in Cochin have wrong plumbing system. In one building, the sewage and sewage is coming separately. In the another building, the sewage and sewage is mixing, and vice versa. After 3 years only, the management or the authority notice the thing, because the plant is not working. The organization got stop notice from the local body. So apart from a sewage treatment plant, from the usage of water, the designing of the plumbing system, the sanitary waste or the plumbing system we using, all those things are much relevant on the success of the treatment system. And the second thing is the social awareness or the behavioral change also we need in this sector. Because when we talk about a sewage treatment plant or a wastewater system, the residents or the public mindset is there is a switch on technology which will vanish every issue with a treatment plant. It can't work like that. We need proper, say, the screening system. If the solid particles also coming with the liquid waste, no technology can treat the water very well. So the screening is very important. If you dump all the solid waste, the paper waste, the plastics, or the hair, or some kind of waste through the wastewater, the operator have to suffer to remove all these particles from the primary stage. We also think these operators are also human beings. They have to separate these materials from the sewage also. So we can't assure 100% assurance on the primary stage, and if the primary stage is not working very well, definitely the secondary stage, the core technology is not working. Again, it affects the tertiary stage. And also, when we take the statistics of the sewage treatment plants, above 70% of the sewage treatment plants, in our experience, is not as per the standard. If it is working very well in a day, when we take the sample, after a couple of days, the result will vary, because the inlet water parameter also is always changing. And also, if you design a plant for 100 KLD capacity, in the case of a residential complex, maybe the occupancy may be less than 50% sometimes. During the weekends, it goes to above 70%. Again, during the school holidays, again the load will reduce. It also affects the efficiency of the plant. So, technology is not only the core thing, the attitude of the people, the skill of the operator who is working on the plant, and also the behavioral change of the residents or the usage of the building is very important as per our experience.
Thank you, Mr. Zakaria. I think your experience with the Swachhata mission has really given you all these insights about the behavioral problems, and I think both the panelists have put forward some major drawbacks or major challenges that we have. Now, I would like to hear from Mr. Jijo. Correlated to these correlated to some of the challenges, could you possibly give some inputs about what should be the startups thinking of with respect to MEP design systems?
Thank you for this question. Actually, see, I can give you a perspective of a designer or an engineering point of view. The challenges in handling the wastewater as far as an MEP consultant is concerned, we need to basically convey the water from where it is generated, and you have to collect it at some point in some area or location where you need to treat them, and possibly whether it's to be reused or not reused, these are the questions that you have. And when you look at the reuse of water, see what are the purposes of the reuse that you are looking into. Most of the large buildings or large format buildings, the recycled water can be used mostly for HVAC, which is actually large cooling requirement, and then for of course the flushing requirements also. And so it also depends on the composition of the wastewater that is generated. So it can vary from building to building. So there is no one rule that is actually fits all solution. If you look at the healthcare facility as such, there will be a lot of hazardous biomedical waste generated, and there are also possibility of waste like radiotherapy. If you look at radiotherapy as such, radioactive waste is generated. So it should not be treated along with the same system. They have to be separately kept. For that, the delay tanks has to be given, and altogether, if you look at the total picture of how the systems are implemented, it all depends on the capital as well as the operating cost, and also the viability of the system, right? If you put in a system that is actually producing extremely high quality output, at the same time costing you a bomb on energy, they may not the client will not operate it in the long run, and because it will not be economically viable for them. So the solution will be basically to find out products. There is actually one of the examples that we have seen recently for reusing the condenser water, what we call the HVAC cooling. They have something called side stream filtration, which actually consumes much less energy, but at the same time producing the right quality or just enough to cater to the cooling requirement. It's not treating them. So the point is, treat water exactly what you need to the to the requirement that you need, rather than treating the whole thing to the the whole extremely high quality for the whole project. So you should be focusing on technologies that will be innovative and producing the right output from the recycled water. Yeah. Thanks.
Thank you, Mr. John. I guess what should be the takeaway is that those who are planning to do innovations in this area should start thinking about applications, right? What application is the source and where do you want to put this back? So I think it's also closely related to what Dr. Praveena was telling about, right? Yes, Mr. Ramchandran, would you like to add?
Yeah, the thing is, today you have a variety of institutions which require sewage treatment plant. Like Bijo said and Zakaria was saying, you don't have a one size fits all. It's not just the quality of effluent coming in. The quality of effluent coming from a hospital differs from the quality of effluent coming from a hotel and from a residential building and a factory. They are all different. They all need to be treated separately. The other bigger problem that we as practitioners of this is concerned is the fact that the flow is absolutely erratic. If you take a hostel, forget about 2-3 days, 2 months the hostel is closed. So the bacteria needs to be further reintroduced into the system. So if the young intelligent minds over here can think of a system which will take care of the fluctuations in the flow, which can take care of a certain degree of, change in the characteristics of the effluent. How you do that, I don't know. But if you can do that, that would be absolutely fantastic, and that would really mean yellow gold. It will be truly amazing if that can be done. Because the water which comes out can also be used. I was discussing with another specialist in the field, and we were thinking, why don't we use this water which every hotel generates? It's now all just being thrown on. Create a water bank. Sell the water to people if you want to, irrigate large areas like stadiums. So there is a huge amount potential for money earning also in this. It is not just pure theory. So it's a great topic. I don't know how we are going to circumvent all this. And one more thing, state intervention, very critical. Without the state putting the foot down and saying that this is what needs to be done, it doesn't matter what we discuss in this and what coffee we have today, nothing's going to happen.
I think responsibility of academic institutions and all are increasing whenever you say this, because policy making and standardization, everything is on the academic section also. Now, if I ask Mr. Zakaria, based on his experience and what he's thought of when he started this company, would you like to maybe suggest some problem statements which the startups can look at with respect to what we have just discussed?
Yeah, when we discuss about the sewage system or the failure or the after effects of the improper sewage treatment, we discuss mainly about the urban ecosystem. But we seriously think about the rural ecosystem, because all the water feed for the state is coming from the village ecosystem. It's from the rivers or small, especially all the Kerala Water Authorities pumping stations are outside the urban ecosystem. And also the small houses doesn't have a proper sewage system. If the apartments have a system or the commercial buildings or the urban ecosystem have maybe a treatment plant. But in the case of the rural ecosystem, it's only a single pit or twin pit. It clearly pollutes the groundwater when during the monsoon season. So this is a serious issue. We have low cost, zero energy consumption technologies are available. We practice implementing those technologies. We can extract energy from methane from sewage, and we can use it as a cooking gas on the kitchen for cooking food. There is an attitude barrier there. Can we use that methane for cooking food from the sewage? So we need to change or give some social awareness to the public. We can use that methane. I can give couple of examples, satisfied examples. They are using the system and they are saving their monthly budget by using the methane produced from the sewage. So what the outcome of those systems are, we can have a proper sewage treatment system on the rural ecosystem with the same investment what we are doing for a normal septic tank and a sock pit with improper design. and also we can reduce the energy consumption or the cooking gas consumption. We can manage the monthly budget also. And also, I have a different opinion about the responsibility of the state only. The state can't do provide the ultimate solution. The public or the entrepreneurs or the new startups have space for addressing this challenge. What we believe within 2-3 years, there are a couple of private investments will come to Kerala for treating sewage with the common sewage treatment plants. If the land is allotted by Industries Department or the state government, investors are ready to invest because there are technologies to extract CBG from sewage. We can use it as fuel for vehicles or fuel for hotels. Currently, we are investing in big plant for solid waste in Cochin. So, if we got the government land, because in the case of the sewage system, there is chances for lot of opposition from the public because public have a lot of negative thoughts or negative attitude about sewage system. I clearly underline that government doesn't have make any change on the system. Everybody have responsibility. New entrepreneurs have to come. If the government supports, we can change the system. And also, the technology updations we need, but also the social awareness, the behavioral change. For those things, the academic institutions have a lot of space on that sector. We can conduct more discussions like this because when we talk about the sewage, everyone have a negative attitude. Can we discuss about the sewage treatment system? Many of the people have wrong concept that we just put the sewage to the water body. The environment can maintain it. In concluding, we have option for entrepreneurs here, academic institutions here, and we have to address the rural ecosystem. We need more investment from the private entrepreneurs on this system by providing the land provided by the state. These are my conclusions.
Thank you. I think that's a very important point for the young entrepreneurs because concentrating on the rural system is possibly better for small scale systems that we generally see from the pitches that we get when we launch these challenges. So that is a very good insight. But again, one issue would be the economic viability. That's why startups have difficulty. So what do you, Viju, could you please give some suggestions regarding how these startups can be in the race, with these? I mean, of course, the problem of centralized and decentralized, we'll come to that possibly later. But what do you think? What should be the strategies adopted?
Yeah, we were discussing almost, we're almost everybody is on the same page basically. See, if you look at what are the challenges that we face on our day-to-day, what you call, the implementation stage, what we have. See, basically you will be looking at technologies that save space. Maybe this one of the priorities that you can focus on because everywhere land is at a priority. I'm looking at the urban scenario, not the rural one. One thing is how technology can reduce the space of the plants, and secondly maybe how automation, AI and IoT-based technologies can reduce human errors. What we have seen mostly is human errors are much more than the machine errors these days, and the machines have become more reliable than humans. And you can have online monitoring. You can have on a 24-hour, 365 days basis, lot of technology. I've seen many of them in action just before our presentation actually. So these are the things we should be looking at, concentrating on how to make things compact and how to make automation, play a bigger role in the new technologies that you are planning to implement. Yeah.
that's that. In that aspect, I think we are moving in the right direction. We've seen that a lot of the new proposals that are coming are based on these internet-based technologies. So that way it is good. And now we'll go to one of the most pressing questions, which is also related to what you both were telling about. What is the relevance of these systems? What is the relevance of rural systems when we are talking about centralized or decentralized systems? So, what is your take on this?
I can tell you from the basis of my experience in Cochin. I don't think a centralized system is going to work in Cochin. And just to sort of add to what Zakaria was saying, I was not suggesting that the government should intervene and install systems. That's not what I'm saying. I'm saying that the systems which are installed need to be checked. Now, how do you do the checking is something which we need to see. As Bijo said, whether we should have this all controlled, IoT and everything should be online so that people will know that this particular building does not have a problem or has a problem. Institute a system by which you can award, reduce some tax if the water they are letting out. Because end of the day, I keep saying, the terrorist is not the one who's throwing bombs. There are a lot of terrorists among ourselves, in this group. If you are letting out water into there is a concept called water footprint. I don't know if you've heard about it. Water footprint is, let's say Bijo uses 50 liters of water and I use 10 liters of water. Who's a better person? Prima facie. I'm a better person, right? You could be wrong, because if Biju's using 50 liters of water, treating it and then letting it out, his water footprint is only 50 liters. Now if I use 10 liters of water and push it into a 1,000-liter pond which is outside, my water footprint is 1,010. So who's the bigger terrorist? It's me. So you cannot look at this thing in isolation. You have to look at it in totality. And just once again, a point to young entrepreneurs who want to start something. I'm sure Aram has got, Zakaria has got ideas for this. The biggest problem we face is not really 500-bed hospital solutions for a hotel like this. That's not the area, because people have got the money for it and they're willing to spend for that. And they are also worried about the fact that the locals will create a problem. There are so many individual houses, we don't know how to treat the sewage treatment, especially in Ernakulam where the water table is so high. You have a problem with septic tanks. There's a joke here for those who understand Malayalam, you will understand. The thing in the KBR states that your septic tank shall be downstream end of your water source, that is your well, which is upstream end of Biju's house, which is why you find E. coli in the water. So what do we? So I'm saying it's great energy. Fertilizer from urine and all. The most basic problem a place like Ernakulam faces is the fact that individual houses they have no idea how to treat them. They just put an STP or you buy one of these things. We have no idea how we are contaminating water. So one of those things should be to address those problems. A system which I'm sure they have got systems which will address single households, 2 households, and then all the other things can be part of it. But this is a genuine problem here. We cannot connect. There is no external sewage drain where you can connect it to. So I think this could be the thing. And once you design something like that, forget about funding. You will have the entire real estate people behind you. If you can come out with a workable system. So money is, I think, a critical issue for all of you. Bill and Melinda will give you only so much of money, but where are you going to get the other money? So if you say that you're going to focus on something which is absolutely relevant to the common man, I think it would work not just in Kerala, it will work across the country. And not only that, you have to design the system for a place with a high water table, and the system has to work in a place with a low water table also. So we have to look at all those factors and then do that.
Can I take from your point that in a city like Kochi, decentralized systems will work, but again you have to use different designs which are suitable, yes, and monitor it, of course, standardization.
Yeah, because if you take Marine Drive, it's clay soil. Water is not going to go down. how are you going to treat the water? And the water is right at the, just when you take.
Right.
You take Kakinad, it's a different scenario. You
Right.
take other parts of Ernakulam, it's a different scenario.
Mm.
The tragedy in all this is that Kerala receives 3 meters of rainfall every year, and Fort Kochi and Vaipin are struggling for water. So there again I come back to this, my earlier point in plumbing, that we have to reduce the water consumption also. If you can reduce the water consumption by 20-30%, your load on the STP reduces by 30%, your power consumption reduces by 30%, your heating reduces by 30%. There's a huge spin-off when you start reducing water. But then again, for sanitation, you cannot reduce water beyond the point. Then it becomes unsanitary.
So I think what you are driving is awareness should be given to the users also. So in that aspect, Mr. Zakaria, would you like to share some experience on what is your experience, what is the strategies that will actually work in these social sanitation drives, which we can focus on immediately?
Basically, when we talk about the technology part, we can't say a single technology or a single centralized system or a decentralized system is the apt solution. It's a mix or a combination system. Just like what Ramendran said, in some backgrounds, centralized systems are working. In some stages, decentralized systems are working. What the opportunity for the academic institutions or the startups is, we have to realize what's the real issue. What's from our perspective, when we check the quality of the treated effluent, it takes time lag to get the result. It takes minimum 3 to 4 days to get the results. From that 4 days, the ultimate the plant character again goes worse. So we can find out any solution or any innovation on that sector. It's wonder, and we can do clinics, social clinics for the public to create awareness, demonstrate how the things are happening, how the sewage is polluting the groundwater, how it affects the human body. Live demonstration can make a lot of changes than the 1,000 ways. So these are the social engagements, opportunities for the new startups on this scenario.
Just one point. Social awareness, I find that the major driver in society, I'd like to say that we have software and hardware. Hardware is what we're all talking about, technologies and innovation and all that. Software is bodhavalkaranam nu parayilla, the awareness that you change your mind. And instead of talking to somebody like us this age group, I don't know if IIT Palakkad can have systems in schools, because they are really, the children are really the drivers. We have not brought crackers since my children went to school, because somebody told them that there is child labor being used in Shivakasi. So even when we want to buy, they stop us. So they really are the people who I think should also be targeted, not just the entrepreneurs and all the other stuff. So I don't know if you can have some small modules which can be shown in schools and colleges, because they are the change makers.
Yeah, I think very good point, and I think we will need a lot of support from institutions and also from government. Maybe LSGDs can help through Water Authority or something to do such workshops in schools. And I think this discussion has actually thrown up a couple of very interesting and very relevant topics for entrepreneurs, budding startup companies to think about, I think. So we realize that we have a lot of task at hand, because see, the wastewater management is also directly related to drinking water, because about 80% of the sewage is going to the open sources from which we are sourcing fresh water. So I think it's quite important that we focus on sewage treatment, and as we have discussed today, I think one thing that has come up is that we should look at improving technologies, like improving the space requirement, time requirement, decentralized systems, adaptable systems. Am I right? Am I summarizing in the right manner? And to have an economic advantage, I think technologies like resource recovery, which Dr. Praveena had talked about, and not considering wastewater as a waste but as a resource. That thought process should be in place, and that is what we need in future. I would thank the panel members.
I'd like to just make one point.
Please.
You're also civil engineer. The point I want to make is that when you bifurcate the streams of waste into three, you see, world over, the buildings are becoming much higher. Okay, 200, 300 stories and massive, and proportionately the cost of plumbing also increases. I'm not here to suggest, I'm not being a naysayer, but I'm just telling you a practical issue. Today, the world over, they're going in for plumbing systems are single stack. Single stack meaning all the waste, soil, everything comes into one this thing, because the cost of plumbing reduces dramatically. We are not able to do it in Kerala because they are insisting on separate this thing. The cost increases by double. So there is a cost element also. So when we go purely on science and say that this is what is available, you need to look at the economics also of actually installing the system. So just a caveat,
I agree.
Just a small point, just to add to what we have discussed. See, there was a discussion on the zero discharge and all that. That's why this thing came up. How many buildings practically can have this zero discharge thing, you know? The point I'm trying to make is, if it was a community kind of application where you have an IT building, you may have a healthcare, then you know, it may not consume, each of them may not be zero, but then if you combine together, no, there is always a possibility of one water from one building which is let out need not be zero discharge, can be utilized by that. So that means clubbing this together, communities may always make a, you know, more sense. So this is a very viable way of making a zero discharge for a community, even though the individual buildings may not be zero discharge.
This is one last point. I'm sorry, I know we are exceeding this thing. Today, every household, every apartment block in Kerala gets water from outside. They bring tanker lorries. I'm saying reverse the system. Make the sewage treatment plant so good that you take the water from the flats. You buy water from the flats. So it becomes a proper proposition wherein you are, enthusiastic about treating the water in your this thing. Yeah, that's the last point.
So Zakaria, would you like to have any closing statement?
While choosing the technology, we have to consider the technical feasibility, financial feasibility, the cultural and social ecosystem where we are. That's the final point I have to. That's why many systems are not working. We implement a highly advanced system, but the society is not ready to accept it. So while designing a system or while suggesting a system, you have to consider the socio-economic, cultural and financial feasibility, then only it works. That's the final point. Thank you.
Yes, I agree. Some of the innovations that and some of the work that we do in academics is sometimes futuristic, but I believe that in the near future there will come a time when environmental expense will start dominating projects and systems, and at that point of time maybe we might have to start changing our perspective about economics. It might be governed by carbon, you know, not just the money. So I'm sure that the world is open to you, all of you who think of working in this area. You have a lot of opportunities, and I thank the panelists for giving such great insights. Yes, I forgot. Yes, I'm sorry. I would now invite the audience to interact with the panelists. Yes.
Hello, good morning everyone. My name is Ibn and I am a part of TechIn. So just as the panelists discussed, cities doesn't have centralized treatment systems. Variation of sewage from building to building, that is a problem. You have adverse public outlook towards STPs or sewage treatments. And like the panel mentioned, you have to have decentralized STPs for individual houses. So I just wanted to know how effective would a mobile STP be as an infrastructure, as service kind of thing, with skilled workers being recruited to man the mobile ST. So how effective or applicable would that be in the Kerala context?
You want any specific panelists to answer your question, or is it an
Anyone,
open question?
anyone.
Yeah, there are opportunity for mobile treatment systems, but again the problem is the treatment system has its own design to treat a specific parameters of the inlet water. So if you got the effluent in that quality, there is an opportunity, and again it is expensive as compared to a fixed system than the mobile system.
Okay, thank you, sir.
A version of this exists in Kerala, because when your septic tank is full, you call these guys who will suck it out and don't ask where they put it.
Yeah. Regarding that, there is a statistics. The requirement of the Kochi is 19 mld per day. The toilet waste collected from Mumbai, the tanker owners. We interact with the tanker owners. They are ready to dewater the unit if any treatment system is available. As of my knowledge, there are 2 treatment systems. I am not sure about the Kerala water. Yeah. Which works, yeah. Other 2 are only 200 KLD, one in Brahmapuram and one in Port Trust area. So there is huge demand in the Kochi city for mobile system. So the challenge is the inlet water parameter matches the treatment system. That's the only challenge.
Water, they take about 5,000 liters to water the median gardening which is being done below the metros.
I thought it's only a mobile collection point, right? It's not a mobile STP. It should be a mobile, collection system, right? He was asking about the mobile STP.
Great idea, but it will be very, very.
But I think it always makes sense if you have a centralized, because every day this this wastewater that is collected is that much of a volume. Then why don't the government, think of putting up a plan which is actually help everybody else, right? Rather than penalizing these people who's been doing this, they are also doing a service to the society, right? Because otherwise, where does it go,
Yeah, but the point is, Biju, if I ask for 1 acre near your house, you will not give. That's the problem in Kerala, because we don't give land for these sort of, even for a water treatment plant. In Marada, I think they had a problem.
Yeah, that's why I'm requesting the academician to do more social awareness, because the Swachh Bharat Mission volume 2 focusing on the liquid waste management, there are a lot of funds. The Swachh Mission officer will explain about that. Funds are available. The main challenge our state are facing is the land availability. So that also we have to focus, because by 2024 the focus will finish again some other challenges we address. So this is correct time to make the social awareness.
Any other? Yes.
Hi, my name is Vargas. I am a construction professional, and I am specialized in MEP contracting and civil. So what we see normally, like I'm just explaining a trend here, the high profile people with enough funding, they can afford the STP systems, as I understand. But when it comes to the mid-range properties like the 3-star hotels or the budget category hotels, the only focus for them is getting the NOC. That is my experience personally. So what they do is, they somehow go around the system and they try to get the license and make the money end of the day. So personally, what I feel is like how Ramchandran sir said, if government brings up a subsidy system, like wherein even like the whole spectrum of the investments is like considered from the money point of view, even basically it's all cost. When it comes to the end of the day, it's all costing. So if I had a client, I'm not specifying anybody, but only the civil cost for him, only to do the concreting was around 25 lakhs. So he literally said, no, we'll find some other way. That's how things work here. So if government brings up some subsidy scheme or something, I think to an extent this can be uniformly managed. That is one. And number two, like what Bijo sir said, like how my friend here told me, like commonly. See, when we look into developed countries, like let's say for example Abu Dhabi, if we go there, I don't think any of the buildings, like most of the buildings, don't have an STP system. What they do is they have a centralized collection system. And if you wake up like around 1 a.m. in the morning, you can see like trucks lined up. What they do is they come to the collection pit of the flats, they collect the waste, and then they go to a sewage treatment, which is a centralized system, which is like maybe 50 kilometers away from the city limits. This is like, I've personally seen it in Dubai and Abu Dhabi and all, many places, but I don't know recently what's going on, but that is happening for like many decades in Abu Dhabi and all. So I would like to know what is your point on these two things, please?
Just let me raise one point there. Their fuel is cheap. Here, having so many trucks coming in, I mean, I think we'll be doing a lot of
ultimately it's a cost
fossil fuel
perspective.
utilization.
Yeah, it's basically a cost perspective.
That's just from an environmental perspective. Yes.
I don't think Burj Al Arab has got a sewage treatment.
No, it has definitely. But if you look into the accommodation area, it's mostly, if you go
Yeah, but like Sunita said, there are, it's not that it is not feasible. You have to figure out, because this, see, it is not the capital cost which is important. It's not buying the trucks. It's the daily running of the trucks which is going to kill you. Whereas if you have a centralized sewage system, taking it into decentralized STPs, that will, in my opinion, be far more effective and cost effective than doing this. I can't think of a way India is going to go this way unless if we find oil under this hotel or something. Without resources for this, where are we going to do it? It's just not possible. That is one. Secondly, there's an environmental hazard. Have you seen any of the garbage trucks which is flying over here? They have no cover. So if they take 10 tons of garbage, there is at least 150 kilos the entire way. So, and sewage is going to be even more drastic. And we with our, I'm sorry to say this, with our Hindustani Badmashi, we will find the nearest water body to let it out. So I think we are asking for trouble to go into all these things. It's a great idea, whether it will work with us.
Is that all from the audience? Right. Yes, there's one more, Gigi.
Yeah, you said about effluent, it takes 3 days to test. That you said it takes 3 days to test. Why does it take 3 days? What is that parameter what they are checking?
Basically, not the parameter only, the efficiency of the system. We know if we give to some approved labs, government approved labs, it takes around 3 weeks time. And if you approach the private labs, it takes minimum 3 days. They say BOD takes 24 hours to 48 hours for the parameter to.
Actually, previously, for example, for glucose monitoring, we took a day to test whether you have what is your glucose level. But now when one touch came, so in my knowledge, I have no idea about the sewage. What is that thing? Maybe the pH value or the oxygen level.
The important parameter is BOD. It takes minimum 24 hours. In some case, the PCB is insisting 48 hours.
Level, they find out
to 48 hours. 3 days, yeah.
To find out the oxygen level in that.
Yeah, biological oxygen demand.
Okay, we'll work on it. Thank you.
So maybe that could be an innovation which you can figure out. Get the BOD level.
Within seconds, like
In fact,
that's what my point. Why don't we get it now? Because we have pulse oximeter, it gives it in a second. So like that we can go for something.
I agree with you. I think in medical field this is what is happening now. Almost treatment at treatment level research is almost now in a very high standard. But now diagnosis has become one of the major research areas.
No,
So maybe
what
we can
I'm
think
saying
of
is what
such
is there in the biomedical field. If you put it in this field, maybe mostly the sensors, we can already there is a very much advancement in the sensor technology and other things. So we can find out which sensor will be suitable for this, then I think the problem will be solved.
It's a good point, because there are water closets now which are being designed, which has got sensors to figure out the composition of your stool and urine. So I joked to a doctor saying that I'll be sitting next to your cabin testing your patients.
One more point is also there. Sir said no, you can go for IoT based for monitoring. There, what is the issue is, I have seen in one article the problem is we can fix the sensor inside the sewage tank, but because of the methane and other things, the sensor gets damaged very easily. So that is also a very big problem. So making an automation is a simple thing. You can have a SCADA, you can very well within a day we can do that automation. But if you think about that life of that sensor, it hardly comes for 1 or 2 days only. Even for the sewage cleaning system, the same issues. That machine or whatever it is, no, it is works. Okay, first time, second time, for 2-3 time demonstration, it is okay. On fourth time, what happens? The sludge gets collected over and it doesn't suit, because the material which we are handling is completely toxic in nature, and it affects the entire system very easily. Corrosion, all these things are much higher. So that is also a potential area where we can work on. Thank you.
Yeah, like what sir insisted. Currently, we are also facing the same, the float switch. The auto level controller, it gets complaint in 2 months' time. So if you got a innovation on that sector, it's a demand of the industry.
Level controllers.
Yeah, Mr. Rajiv.
Hi, my name is Rajiv Kumar. Just want to add on to what this discussion happened. I was part of the first EcoSand forum, which was set up by the Government of India, and there were a lot of studies on how the human waste goes back to the nature and the effect of that on our environment, especially the soil and the water. It was found that it takes at least 75 days for the fecal matter to neutralize. The government has a different standard. It doesn't take into they don't accept various parameters which are very important. Like for example, each one of us we take medicines, we take drugs, we go out, we observe all the pollution out there, and that goes into our stool. But that doesn't neutralize that easily. In the urban area, even after 75 days, the fecal matter doesn't neutralize. That's a big challenge which is there. And a lot of research is happening in India, in IITs and other center of excellence abroad. Some of our study, some work that is done in MIT in USA, quite a lot of stuff is being done. But this is something, there are a lot of things which are not taken into consideration by the government, by the agencies on various areas. That's basically because these things are too big for them to address, and that's a great opportunity for research centers and startups. The solutions are there, cost-effective solutions. Second thing which I want to point out is there is a way to get infrastructure funded, and that's by bringing in the concept of ROI into the project. How do you calculate the return of investment on an SPT? So that has been done in some societies, and there is funding. They take funding from World Bank and IMF and other organizations for that. But unfortunately, our policy makers and our bureaucrats don't take into consideration the ROI, because ROI can fund large projects. Thank you.
Thank you for that insight. I think we can now conclude a couple of things. One is that definitely we have a lot of problem statements open, and technology intervention is the need of the hour, and possibly, of course, circularity has to be brought in, whether if it is waste management or not, circularity has to be there. So I think the takeaway is that we should all work towards making much better sewage treatment systems, and that's the way to make this world a much better place to live with. Thank you.
Thank you
panel for enlightening us on plumbing solutions, sewage management and practices from your diverse experience. Now I would like to invite Dr. Praveena to hand over the memento to Mr. Ramachandran Pullat.
This is what we were waiting for.
Thank you, ma'am. Now I would like to invite Rajarajiv Kumar to hand over the memento to Mr. Bijot K. John. I would like to invite Mr. Praveen K.S. to hand over the memento to Mr. Sakriya Joy. Thank you, sir. Now we can start our second panel discussion. Please give a warm welcome to our panelists, Rajarajiv Kumar, Mr. Praveen K.S. and Mr. Sarosh Kothadkar. Let's have a brief introduction about our panelists. Rajarajiv Kumar is currently the CEO of Lakshmi Ramavarma Capital Advisor. He is a serial entrepreneur, investment banker, technology innovator and strategist with 28 plus years of experience spanning all facets of sales, marketing and branding in a diverse sector across India, UAE, SEA, USA and Latin America. He is a postgraduate in computer science, management and foreign trade with additional training in clean technology and quality management. Rajarajiv Kumar has worked extensively in UN Sustainable Development goals involving ecology and environment and impact sector in both professional and advocacy roles, and has also set up India's first social movement for promoting sustainable cities. He is a mentor and associated with IIT startups. Pleasure to have you with us, sir. Welcome. In the next, we have Mr. Praveen K.S. Mr. Praveen K.S. is presently the Director, Liquid Waste Management, Swachhata Mission. He has more than 20 plus years of experience in the water and wastewater management sectors, out of which 3 years were in academic research and 2 years in industrial R&D. He has strong mechanical and civil engineering background with MTech degrees in both mechanical and civil engineering from the University of Kerala. Before joining the present position, he has been working with Kerala Water Authority for about 19 years in various capacities and roles, from assistant engineer to deputy chief engineer. He has also been a resource person for various training programs in the Center for Water Education and is an author and co-author of more than 15 publications pertaining to liquid waste management. Warm welcome to you, sir. Next in the panel, we have Mr. Sarosh Kothadkar. Mr. Sarosh is currently project manager at Global Sanitation Center of Excellence at IIT Palakkad with project experience in managing public and external funded assignments in the water and sanitation domain. He is a water resource engineer with MTech and MBA and has about 20 years of consulting experience in urban and rural public infrastructure projects and policy. He has handled multiple assignments with World Bank, ADB, JICA, premier consulting firms in India and abroad. He is fellow member of Engineering Management Societies IEI, ASCE, IWRS, IUCN, IAM, ISPRS, IAHS, IWWA. A very warm welcome to you, sir. Our moderator for the session is Dr. Praveena Janardhanan, Assistant Professor, IIT Palakkad. Requesting all the panelists and Dr. Praveena to come up.
So again, good morning to all, and first of all, let me welcome all the panel members for this panel discussion. And we have Mr. Raja Rajiv Kumar. He has a lot of experience as a entrepreneur, moderators, innovations, technologies, etc. And also we have Mr. Praveen. He has an experience in water and wastewater management sectors, and we have Praveen, Mr. Sarosh, and he has experience in public infrastructure facilities. So, welcome to you, sir. So the theme that we are going to discuss today is septage management, and technically septage management must be done through a proper sanitation chain involving containment, emptying, transportation, treatment, and end disposals. It's a fact that more than 70% of the urban population of India is dependent on on-site sanitation systems like septic tanks and pits for the disposal of septage. But in many on-site systems, limited attention has been accorded to proper construction, operation and maintenance, and the management of septage generator. So we must consider all technological interventions to upgrade and enhance the efficacy of every process of sanitation chain to acquire proper and effective septage management. Hence, in this panel discussions, we would like to discuss and brainstorm about the modalities to work on these aspects and request the esteemed panelists to open their thoughts in 1 or 2 minutes. Then we can continue our deliberations. So my first question to Mr. Raja. So we'd like to know about the various, what are the advantages and barriers for startups in the domain of septage management and sanitation technologies.
Yeah, thank you. Warm welcome. Good morning to all of you, and thank you for having me on the panel. Basically, septic management, septic systems, as we had a talk right now on sewerage. Because of its nature, like for example, in your talk, you mentioned that we're going to reach 9 billion population within the next 20 years. The problem that we have is the density of population is not uniform, it is spread across. So what happens is that in many areas, because the population density is very high, you have limitations in a matter of space, in a matter of opportunity. So the big challenge over here is the land, availability of land for putting up the system. You need to develop solutions based on the context, based on the nature of the locality, of the kind of the waste that comes into the septic tanks, and also on the ownership pattern. Right? For example, you got government-owned systems, you got decentralized system at homes, you have collective systems in some societies, and you have privately owned systems in large, let's say, industrial parks and commercial parks, in education institutions, etc. So each of the solutions are different. So we have an opportunity here for the startups to design systems that are efficient, not in terms of efficiency of operations, but also efficiency of recycling the waste that comes in. So because we're talking about net zero waste, we're talking about a circular economy. So this is a big challenge here, and a lot of research is being done. The problem that we face is how do we commercialize this innovations that come in. For example, we have technology which is highly scalable. You can purify, you can recycle water, wastewater, septic waste from a small container size to a city size. The same technology can be applied, but at what cost? The second thing is bringing in intelligence. Now, IoT has played a very significant role in systems, not just decentralized systems. I'm sorry, not just centralized systems, but also in decentralized systems. it's not just about efficiency, it's also about removing the sludge and repurposing it. So the most important innovation which is going to come in is from two areas. One is the biological systems, and the second is using artificial intelligence. While in Bangalore, when we ran Project Agastya along with the government of Karnataka, we tried experimenting various models with BWSP and BMP with moderate success. The problem that we have is what I call social irresponsibility. We are all good about talking about social responsibility, but it's as long as you are social responsible. Don't ask me about being responsible. So we need to build up collective, we need to build up participation. So PPP would be a good model for that. But all the more, we need to change. There are a lot of issues with the regulatory framework which need to be addressed. Because regulatory framework doesn't encourage new innovation being applied, at least on a experimental basis. So there's going to be a big challenge. But opportunities are there. There is a misconception that solutions are expensive. So it's very difficult for private parties to get into it. But there are ways, means to have inexpensive solutions also, which is being tried out in small communities on that. And you also need to look at how do we generate energy from waste. There's a small example. There's a building in Bahrain where every time you flush a toilet, it lights a bulb. And this is nothing new, right? So you have opportunities in applying new technologies which are cost effective. You have, we had somebody here who's talking about design of systems. So redesigning systems. We don't have an integrated approach, which is a big challenge for us. You need to look at an integrated approach. At the same time, looking at how each players play a significant role in that overall picture. So those are the opportunities, and the disadvantages, again, I'll repeat, just to sum up: regulatory approach, regulatory framework, social responsibility, lack of cooperation, which comes from that, and again, awareness. So we in Bangalore, when I was in Bangalore, we conducted several awareness programs with moderate success. The problem is not that. Everyone thinks it is the government's responsibility. It is not the government's responsibility. Government is just a facilitator, is just a service provider and a regulator. The whole responsibility lies in the society to ensure that we have efficient management of waste as well as waste systems. So, thank you.
Thank you, Mr. Rajiv Kumar. So basically, I think the major barriers that we can look into the septage management is the availability of the land and the developing appropriate technologies. So we develop a lot of technologies, but probably the technologies will not be appropriate in a particular locations, but may not be appropriate in the other areas. So, and also we, as you mentioned, that a lot of IoT-based technologies with the recovery of energy and other materials from the wastewater. So that would also help to achieve or minimize the limitations posed by the current technologies. Right. Yeah. So thank you. That was a good insights, and we will move to Mr. Praveen. So basically, Sujita Mission has a lot of activities in urban as well as local areas. And my question is, what are the liquid waste management programs that Sujita Mission engages with the urban and local bodies?
Distinguished panelists, moderator, and dear friends, first of all, let me thank you, all the organizers, for inviting me to this elegant discussion. Shweta Mission actually it was formed in 2008, amalgamating the erstwhile Kerala Health and Sanitation Mission and Clean Kerala Mission. Those two were amalgamated and Shweta Mission was formed as a technical support unit to the local self-government. As per the constitutional mandate, it is the mandate of the local self-government to do waste management, both in solid and liquid waste management. So, in order to support them in the technical aspects, Shweta Mission was formed. But later on, with the Swachh Bharat mission, both urban and rural, the phase 2, the emphasis is more on liquid waste management. More than 50% of the funding is for liquid waste management. Now, we lead the mission organizes for the state. We are bound to see that the local bodies are executing the liquid waste management projects. Close to around 1,000 crores are earmarked for the liquid waste management both in urban and rural sector. The approach is that something like that, what Government of India is advocating is that for the urban sector, it should be decentralized or centralized. Sewer network plus STP in core areas with facility for co-treatment, and for fringe areas, it should be strengthening the on-site sanitation system and the regular desludging with the help of the co-treatment facility in the STP. And in the intermediate areas, what they are advocating till the network is expanded. The ideal situation is that it should be networked. So till the network expansion happens as an intermediate measure, in order to prevent water pollution, identify the drains which are carrying the wastewater to the river or water body and intercept them and divert them to the STP. That is the approach that Government of India is advocating. And in the rural side, what they are advocating through SBN Gramin is that it should not be networked STPs. Basically because it is based on a concept that the water supply in rural areas will not be sufficient to cater to the velocity, self-cleansing velocity of the sewer networks basically. But in Kerala the situation is different. Minimum 100, as you all may be knowing, 100 LPCD water is required for maintaining the cleansing velocity. In Kerala, almost that irrespective of the urban and rural, we are supplying the water if it is a piped water supply. So even then, the approach is all over India. The concept is that standalone fecal stage treatment plants should be there, and the on-site sanitation system should be strengthened. That is a basic thing. So these are the two approaches which we have to carry on. So this discussion I will take it as a continuation of the discussion carried out earlier regarding sewage management. As you all aware, sewage means as and when the water is wastewater is generated, it is carried through the pipe. There is no storage. But in case of septage management, when you say there is a containment system, and the containment system is designed for only, actually as per the actual design, it should be only 48 hours storage maximum. So the rest of the water, where it go? Though sedimentation happens in the containment zone, then the remaining water should not be let down to a drain. Why I am saying is that normally there is an Indian standard for the on-site sanitation system. There are two standards only. I don't know whether any other standard is there. Only is IS 123140, which is corresponding to the leach pit, and IS 2470 corresponding to the septic tank system. Normally when we say about the on-site system containment, we only construct septic tanks or some tanks. Actually the IS 2470 has a part 2 which mentions about what to do with the effluent water. Because you cannot store for 2 years. The water which is coming out of your flushing toilet, you cannot store, you cannot construct a containment system for 2 years. The maximum capacity IS recommends is for 48 hours storage. So what happens after that? As and when, suppose there is a, we are constructing around 1000 liter storage for a 5-member family, septic tank. So only 1000 liter water will be stored. After that what happens? Whatever water is coming in, it goes out. But whatever water is coming in, it will be stored for 48 hours and if settlement happens, the solid settles and the effluent only passes out. So the IS recommends that, IS part 2 recommends that there should be a treatment system for the effluent. You should not pass the water effluent from the septic tank directly to any drains. But unfortunately, even the standard specifies the discharge standards for the effluent from the STP. It doesn't mention any standard, any parameters is mentioned for the septic tank effluent. It just mentioned that effluent shall not be directly discharged to drain. So there should be a treatment system. One of the treatment system is sock pit, they are recommending. Now, how much sock pit? This I am mentioning because when to go for a sewer network system and when to go for a on-site sanitation system. The cost part is different because what we ultimately want is that the sanitation system which we are offering to the people, whether it is urban or local, it should be inclusive and equitable. The cost aspect, if I should not pay more or I should not incur more cost for not connecting to a sewer system or connecting to a sewer system. Suppose I have a septic tank. For desludging, every 2 years I have to pay something. For the sewer network, every month I have to pay some cess. So these should not be variation between these. Whether I am opting for an on-site sanitation system or an off-site sanitation system, my amount which I am incurring should be equitable. Inclusive means it should be everybody in the society should. So that way if we say when to go for a sewer system and when to go for an on-site system, the academic institution has a scope to study. I think nowhere in India it is mentioned that how much septic systems per kilometer square we can have. Because if we say EPA specifies a standard that this should be per kilometer square, how many septic systems should be there. More than that, it will contaminate the groundwater. So something like that, if you can go and research and find out some value which we can recommend to the government of India. Because what I feel is that in the on-site sanitation system, the standards are pretty old. More than if you say 1987, 1984, you can see the revision. After that, no revisions has happened. Because even India has not bothered about the on-site sanitation system, strengthening on-site sanitation. We have dreamt about the expansion of sewer network, which is just a dream. If you see the history of sewer network system in India, the Trivandrum, we have not in India, I will say Kerala. The Trivandrum, we have a 107 MLD plant. You may be aware. When the design has been done, the design has been done in 1938. 1938, much before the Kerala state was formed and in India got independence. Still, I also agree that the city has suspended what at that time it was 1 lakh population, now it is nearly 10 lakh. But still, if the coverage is taken, it is between 25 to 30%. So the network expansion will not happen as envisaged. If we say the Guruvayur sewer treatment plant, which has been commissioned recently, 2 years back, it has started in 1971, the plant. So the network sewer system expansion and maintenance is a problem. But in highly populated places, like I see told, the on-site sanitation system becomes a burden. If it is based on the soil dispersion system. So we have to find out, the innovation part is what you can do that, you have to find out some other feasible solutions for the secondary effluent treatment of the septic tank. Even Jokasu, morning MD was mentioning, Jokasu needs 6 months desludging. It is similar to, it is whatever improvements are taking place is in the septic tank system or the containment system, not on the secondary effluent treatment systems. And there is no standard. I think we have to recommend for some standard for the effluent from the septic tank. That is one part whether these academic institutions can contribute, also innovate. And one of my out of my experience, one of my advice to innovators here is that don't try to reinvent the wheel, because what I feel is that we have conducted so many similar small scale experiments, hackathons, then innovation hubs, something like that. Whatever you find that two things are there. Some people come with the idea, they research for 1 year. After that, they find that there is a product already in the market. If you say BOD sensor is available. I will say mobile treatment unit, what you are mentioning, is available. But you can improve upon what is the gap in the mobile treatment unit. Mobile treatment unit, there is a mobile treatment unit available for septage treatment plant. It is developed by Wash Institute. You may be aware of Wash Institute. But what I am finding is the problem is that the liquid part is okay. Normally you see the septage treatment, what you are basically doing is solid liquid separation. Solid part you treat wherever is septage or sewage. It is two streams. But in the septage part, first we separate the solid and the liquid part you treat separately using a normal STP procedure. There is an STP in every FSTP and there is an FSTP in every STP. So depending on the liquid solid content variation, the technology differs. That is the basic thing. So there is a separation process. After that, the solid, there is no treatment. Solid is disposed as such. There is a deep trenching what they recommend. Because it is going to every house. So they will make a trench and dispose the solid. So if you recommend it for a whole city, it is not feasible to store the solids or dispose it in a trench. So that part if we can improve upon. A mobile treatment unit which can treat both the solids and the liquid, take care of. Now the liquid part is safe for discharging in the existing. So you have to find out what are the gaps in the existing. BOD sensors are available, but the BOD is the amount of oxygen required for the bacteria. So it's a biological process. If you want to actually measure it, you have to do it in a lab by incubate. In a incubator, biological incubator, you have to feed the bacteria. So that takes 3 days. That is a standard. BOD 3 days is the standard. But when you go for a sensor, it measures indirectly some other parameter which can be extrapolated to the BOD. So that the calibration is also there. So you find out what are all the disadvantages of the existing sensor and then you improve it upon. Otherwise, your whole exercise of research will be waste. That is my simple thing. Then second part, academic side, one more thing is I want to, the solid part, even for STP or FSTP or fecal septic treatment plant, there is no standard for the biosolids which remain after that. Except that it should be free from pathogens, we all say, there is no standard mentioned anywhere. So we have to find that what should be the standard. Because otherwise what will happen, all of a sudden we will be subscribed to some other standards, international, and all the existing plants will not be able to cater to that. Recently you might have seen that NGT has revised all the norms of the effluent standards from less than 30 mg discharge standard to less than 10. So that becomes all the STPs existing becomes irrelevant. Then the Supreme Court stayed that order, saying that you cannot impose such a thing, saying that the standard should be that much stringent. So that is one thing. Then another research aspect what we can do is that the sewage, the characteristics, sewage we see what are the parameters to be taken, when to do the sample, all the discussions we were discussing about the fluctuations, all these things, CPHO manual clearly mentions. If you design an STP, when you have to take samples, how many times you have to take samples, for how much duration you have to take samples, all are clearly mentioned. But in septage part, it is silent. And if you see septage, there are few publications. One is by CSE, Septage Management Guide. There is an advisory by CPHO. If you see, there is a drastic variation in the BOD itself. If you say single parameter BOD, one book recommends around 2000, other recommends around 6000. And we have mentioned, we have few septage treatment plants. In Ernakulam we have 2, in Kalpetta we have 1, and we have co-treatment facility in Trivandrum. So we have mentioned we have measured the BOD in the samples. We find that it is varying from 2000 to 6000. So what should be the characterization of the septage for the design? This will make the design much complicated. And second part is that the grey water sometimes we forget. When we say about sewage, we should say about septage plus grey water. Because if we the wastewater, if it is 100 liter, if you say 135 liter, 100 liter, almost 108 it becomes. So 100 liter if you refill take, out of that 70 is grey water, only 30 is the coming as black water which is coming to septage. So the 70 having a lesser BOD but with a higher volume, the total contribution to the BOD load to a water body is very high. So when you say septage management, it should be complemented by a grey water management system. These are all the opening remarks which I want to mention. Thank you.
Thank you, Mr. Praveen. It was a wonderful points that you have mentioned. So predominantly the points that you have mentioned is, the septage management, on-site septage management. We have septic tanks in every houses, but the technologies to treat these pollutants predominantly consist of carbon dioxide and the nitrogen and phosphorus. Also, there are technologies available. The post-treatment, the effluents. The effluent part is like reed bed is one of the technologies currently practicing. But there is a solution for water part, the effluent part, but then the solid part is one of the crucial that you have mentioned about the mobile fecal sludge management treatment systems. So so we have to find out what would be the appropriate treatment technologies for this solid part. The solid part, it can go to compost, but the viability is we have to experiment it. And also the standards. See, in septic tank, we are not only facing the carbon or nitrogen or phosphorus. Nowadays, we are facing the micropollutants as well, like the pollutants in the antibiotics. Yes, and also there are shampoos, cleaning chemicals, etc. So we need to focus on that as well. Although their volume is very, very less, the concentration I'm talking about, but when it comes to the effluent, this also matters. So if you discharge it simply into the water body, that is also very, very, very crucial. So we have to look for all these things, as a standard. So you have mentioned a very valid point. We need to have a proper standards for all these things. Yes. So thank you for mentioning all these things. So of course, we have a septic tank, or if I have a septage treatment systems, that will benefit the community as well as environment. So my next question is to Mr. Saroj. How do communities and the environment benefit from fecal sludge and septage management?
Thank you. First of all, I'm grateful to be in this panel with eminent panelists, and thanks to Gigi for that more than kind introductions. Coming to the topic itself, we are talking on fecal sludge and septage management. Before going into that, when we visualize our own personal lives, we all have been having septic tanks in our individual households for a very long time. Later on came this centralized sewage treatment plants and all the other facilities, organized facilities for scientific management of sewage. And this question or this debate on whether a centralized system or a decentralized system would be better has been going on for several years or several decades. And we have our own constraints or our own special situations here in Kerala when we compare it with the other parts of the country. So now, if you would ask me, I would say that a system which would complement both the centralized and decentralized facilities would be the one which would be suited. It's a case-to-case basis. Like where we can go for centralized plans, we can definitely do that. Definitely, we need all the centralized network system to link to these plans. And wherever we have left out pockets or where we have areas where we have shortage of land, all these places we can go ahead with these decentralized systems. So that would be possibly an appropriate approach which we can adopt. Though this is subject to a contest where the policy also plays a major role. Kerala has been following a different model of development wherein decentralization has been even more focused due to many, many factors. So that is there. But now when we come to this sludge or the septage itself, it's basically the solid part which is coming out either out of the sewage treatment plant, which we call as sludge, or the solid plus liquid matter which is taken out of our septic tanks, which we call septage. And the treatment process has some similarities between the two based on the composition of it. Now when we think about the older ways of managing sewage, I mean, we all used to have bigger houses and bigger plots. We had bigger tanks itself and a soak pit which would disperse all this water content to the larger area, and the solids remain for a very longer period of time, say 15 or 25 years. I mean, in my experience, I have never seen my septic tank getting emptied. So it has been lying for several years. Maybe it has got its own design problems, that's why it is not getting emptied, but that's the fact. So nowadays we don't have that luxury of bigger plots and all those things. I mean, these are like 5 cent plots or 3 cent plots where you have a well. I mean, even having a well is a luxury these days. And we have a septic tank which goes into the, water source of your neighboring plot. So that's how life has been going on. So in this aspect, I would put that, this septage or fecal sludge treatment facilities which have been coming up or have been prioritized by both the central and state governments is a novel initiative or a good initiative which would help in reducing the pollution of our water bodies as well as the land areas, and it will help in ensuring better health of the community. And when it comes to these facilities, what I personally have observed that it triggers also the implementation or putting up of personal better designed septic tanks in individual households. I mean, when communities see that there is a provision wherein you can take the semi-treated septage to a facility where it can be treated in full, there is more push in putting up these type of facilities in individual premises. Otherwise, in the end of the day, when we are emptying it, we are putting it all over. So, I mean, that doesn't make sense. So with that note, okay, now coming to the question which has been asked, that was on the environmental and the benefits it's creating for the environment. See, I mean, from time immemorial, development has been happening close to water bodies. That is how our civilizations have developed. But now when we see, we have seen civilizations propping up near drains or near water bodies which are carrying wastewater. That's now the present situation. Many of our urban bodies, we see that, sorry to say, these are mostly disadvantaged communities which are getting inhabited near these wastewater bodies. Naturally, there is a problem, and there is a problem for water source for these people, as well as they don't have the right facilities, so they are disposing their wastewater into these water bodies, making it more polluted, and which in turn comes back to them, affecting their livelihood, and their whole life is in danger. So thinking in those aspects, these fecal sludge treatment facilities or the septage treatment facilities which we are adopting would help in improving the overall environment, as well as it will help in improving the health of these communities. Then there are, when we talk about these disadvantaged communities, there are mostly community septic tanks which we are employing instead of individual septic tanks due to lack of space or due to lack of resources on their part to put these facilities. So here also, instead of dumping the overflow to these water bodies, we now have a better mechanism wherein we can take it to these facilities and do the treatment. And there are reuse and circular economy aspects of it which are coming up that would bring in more entrepreneurial aspects to it as well. So even otherwise, once we see that there is a facility being provided wherein, we can get our waste or the solid part of our waste taken there and treated, then it helps in bringing an overall push to implement more of these sanitary practices. And we all know that a lot of health hazards are getting prevented due to these aspects. There is social upliftment of the community as well as water body rejuvenation due to all of these. And this UNSDG 6, which is on clean water and sanitation, has already been addressed, and along with that, good health and well-being as well as equity and inclusion aspects are getting addressed through SDGs 3 and 10. I mean, these are the associated aspects of this activity. With that note,
Just thank you, Mr. Sarosh, for sharing your perspectives in this area. So basically, that what we have to take is this septage management in the community is really essential for improving the sanitations and well-being of the community, and as well as preventing the diseases. And at the same time, always we have to have this confusions regarding that whether we have to go with centralized or decentralized, but we have to adopt these technologies based upon the various constraints, various factors, etc. But we have to really look for, is there any effective management or effective model for a sustainable sanitation solutions. So in that aspects, my next question is to Mr. Raja. So so with your international experiences and engagements with innovators and startups in the domain, so what are the best adaptable models for effective sanitation solutions?
Okay, we had a good discussion in the morning, which went a little bit, which actually touched on some of this. The best solution is always a solution that can be adapted for a wide range of purposes. So that is the standard thing. What is happening around the world is now there was talk about mobile treatment facility. There is research and there are models that have been created for that. So, like Mr. Praveen said, quite a lot of what we need to do is already researched, and there are a lot of models and templates that we can follow, and standards and benchmarks that are there. But that can be improved a lot. There's a lot of research that is happening in that area. A lot of people are trying to commercialize those research into commercially viable, scalable, and sustainable ventures. And that is one great opportunity. One of the things that we have been advocating is when we had Project Agastya and we had the various think tanks, EcoSan and the city planning, what we did is we said, let's have grand challenges where we bring together the ecosystem. And in every ecosystem, there is the regulator, there is a control mechanism, and there are commercially parties with commercial interests. And many of these entities with commercial interest also has some level of technology with them, which can be used for kickstarting a process where you can keep on improving on the technology applications. Now, septic tank for many people is of the least of the priorities. Like what Mr. Sarosh said, nobody looks at it. Many of septic tanks lie there for 25 years, and at some point in time, it gets full. But what if? I mean, why do people create large tanks? Because they don't want to open it, right? Because it's a big nuisance for the neighborhood. In olden days, we had large plots. That was not a problem. Today, in the city areas, you have very small plots. In industrial parks, in commercial parks, there's a different scenario altogether. You can't shut down the factory for cleaning up your tanks. It's not possible. So, quite a lot of research is being done on how to break down the sludge within the system, and how to do it in a very effective manner. Some POCs have been done. But the problem here, what we're facing is how do we scale it up? So those are things that have been happening, but it is happening at different levels. So policy makers level, bureaucrats level, city managers level, institution level. But I believe there's a great deal to be done. I mean, we're looking at how to engage these people who have been manual scavengers, how to rehabilitate them. But this is not only a problem for India. You have this problem even in large developed nations, and especially small places like Singapore and Hong Kong, where there is a great deal of legacy society and problems, as well as high density of population with little resources. So there is funding for that. The main challenge everywhere is people, if this incubator knows, it's the major challenge that every startup community faces, how to get funded, right? But globally, we are taking that focus from getting funded into bringing out commercially viable applications of technology and innovation, right? And how to do that, how to scale it up, how to modify it, and how to enable other people to replicate it at a fast pace. So these are the initiatives which are happening at a global scale. Great more has to be done. We have opportunities to improve employability of unskilled people, marginalized people. We have scope, the very large scope to utilize funding mechanisms in a very effective manner. At some point in time, we have been looking at return of investment of projects. It could be a septic tank, it could be a large treatment facility for a city. It could even be things like a tank in a submarine or the ISS, International Space Station. So these are things which are happening. But one more thing I want to talk about is there are a lot of unrelated areas which deserve attention when we talk about sewerage or liquid waste or septic tank. Because Mr. Praveen did mention a very valid point that 70% of the water or the input that goes into a tank is normal water with chemicals and whatever way, the flush water for that matter, or even rainwater sweeping down. So so what happens is that if you look at the capacity of a tank, you need to factor in 4 times the load factor, right? So how do you create a tank which is expandable, right? So these are kind of research that has been done. We ran a few challenges and even with the Gates Foundation, and quite a lot of interesting ideas came out of it, interesting models came out. We looked at how to commercialize them, how to replicate them, and how to support them with public money, while at the same time focusing on the return of investment. And public health was also an important factor. Thank you.
So thank you, Mr. Raja. The point that you have mentioned about innovations in this area is intriguing. So what I felt that basically there are a lot of innovations happening. However, it's not coming to the commercial side. So whatever the technologies that we are developing, we have to find out whether it is technically feasible and also economically viable. So the research or we have to look for our startups or whatever the things we have, it should go in that directions.
I think we're just focusing only on a small part of the larger space. For such kind of socially relevant areas, you need to first focus on developing an ecosystem that works together, right? Otherwise, a startup alone cannot do anything. Like, for example, I have a venture which is working on advanced AI that can be used for utility management, utility resource management. But the problem over there is they have only the technology. But in order to test that technology, there's quite a lot of work that has to be done, right? For example, you got a septic tank. You can't dig into it and put in that, the sensors or the chemicals. It's not possible, right? I mean, you can't flush it into the toilet. It's not possible. So you got all these drawbacks, but this can only be solved. So when we started the EcoSan movement, we had to import toilet equipment and fittings from China because we didn't have any manufacturers here. Manufacturers came in and they said, you create the demand for us, we will manufacture. The government said, we'll give you subsidies. Said, it's not possible. So then what we did is we went to small players like pottery guys and got them to make some fiberglass and ceramic utensils. We got some fabricators to get in the fittings, all those things. And then we had to go out to the village, rural areas to try them out because nobody in the urban areas was willing to. Hotels, I mean, I ran hotels and I offered to put up a waterless toilet system in my hotel. But my management said, my staff said, no, it's not possible. We can't do it because being a star category hotel, there are parameters. We can't afford that. So we went and tried it out at government, tourism departments' hotels. So the challenge over here is you need to focus on building a good collaborative ecosystem fundamentally, and this incubator and incubation system must sit on top of it and work. The government, as I said, can only play a regulatory role. They can only play a service role. The responsibility is on all of us, entrepreneurs, researchers, academics, and the society.
I think this is a collective efforts at developing an ecosystems to implement those technologies, and at the same time, the scale-up portion of these technologies and funding is also very, very crucial. Yeah, so thank you very much for sharing all these insights, Mr. Raja. So when you look into the sanitation chain, the role of sanitation workers are very, very important. So my next question is to Mr. Praveen. So please brief the best practices or community drives adopted by Sujita Mission in effectively engaging the sanitation workforce.
The sanitation workforce actually includes both solid waste and liquid waste management. We will use the term Safai Karmachari in the Government of India norms to mean the end user or end person in both the chains. That means a waste picker in solid waste or the desludging person in a liquid waste become a Safai Karmachari. So in the case of the sanitation workforce in the solid waste management, we have around close to 30,000 Haritha Karma Sena workers with a part of the Kudumbasri, as you know, that is a self-help group. So they are their earnings are from minimum 10,000 government is assuring as of now. But the liquid waste management part, as I told you, the treatment system is very limited, and hence most of the players are on the private side and unorganized. So we have started a mapping facility to register, but they are reluctant little bit to come forward and register because as of now, as earlier panelist has told that since there is a no treatment facility, most of these collected sludges are dumped in open fields and water bodies. So they want to ensure that it is not penalized until time the treatment systems are in place. So the process is going off for registration. Then there are a lot of schemes for training them, then providing them PPE kits. There is a National Safai Karmachari Finance Development Corporation which provides loans to these workers at very minimal rate, not only to these persons, including family members, their welfare, their overall development, education, all these things they are supporting. So we are in close discussion with them. But the problem is that either it should be microfinanced through some self-help groups, or it should be through the either the ULBs or the local bodies, they should process the applications, all these things. And already lots are provided for education of these family members, and all this. Kerala is number one in providing that financial assistance in terms of the Haritha Karma Sena and other aspects. But the desludging, as I told you, the workers are almost the private and unorganized sector, and we are slowly having discussions with them. And Shivitha Mission has proposed a standard operating procedure for desludging with certain privileges given to these people, like that insurance cards, then health checkups, like this. That is under the consideration of government. Government has to issue as a GO. So these are also we are taking up in line with the GOI things. Because as of now, as per the amendment of the manual scavengers, as you know, there is a prohibition of manual scavenging act. So that prohibits manual scavenging, and as per the definition, we don't have any manual scavenging. But we have the hazardous entry into septic tanks and sewer lines that we have to prevent by providing these PPE kits and vacuum desludging equipment, so that there is no manual contact. And in case any emergency contact is to be there, that should be done only with the permission and with the approved safety gears. That is the one thing. And I think Government of India is launching another scheme in within 2 or 3 months called Namaste. That is for rehabilitation of this workforce. We are also going to utilize that scheme also for the welfare of the sanitation workforce. And we have done a massive campaign in order to, as earlier panelist and our dignitaries told, the problem with the establishing sewage and septic treatment plant is actually the public protest. The land in the septic treatment plant, land is not a big issue, because in sewage it is an issue, because the sewage treatment plant can be so that ideal place should be available for the installing the STP. But septic treatment plant, as the septage is carried through a lorry, any place feasible for the transportation of the sludge is a feasible place for the septage. So land issue is not as severe as in the case of STP, because the local body itself is maybe having some lands, some abandoned lands, and other than that the public is maybe there is no, but on the way there may these. So in order to make them aware, though we say that this is a health hazard, we don't medical hazards, because one thing is that we are drinking water after boiling, so normally there will not be any pathogens. And second thing is that the piped water supply is also treated water, chlorination is done, so the pathogens will be killed. So that way we cannot directly relate the pathogen content or the health hazard with the history of illness and all those things. So this is an invisible problem to them. So in order to make them aware of this problem and to make a massive involvement, we have done a campaign with we are testing that fecal coliform content using field test kits. So close to 70,000 samples has been taken all over Kerala with the help of the sanitation workforce, the people's representatives, all these. So we have just distributed the kits and asked them to just to test the sample and give the result. So we have maintained a GPS app for recording whether it is yes or no and the GPS location. So we found that around 79% is having contamination. So that way also we have utilized this workforce. So now the people are aware that there is a emergency situation. It can translate into a medical emergency sometimes. So that way this sanitation workforce is involved in almost all the activities. That is what we are doing. Thank you.
Thank you, Mr. Praveen. So we're glad to hear that government is supporting this sanitation workers in terms of their financial assistance, overall well-being, health checkup, etc. And also there is an SOP for desludging operations. And also this work is very intriguing, the GPS work, and we can find out wherever the fecal contamination is very high, and it's sad to hear that 75% of the areas where fecal contamination is very, very high and treatment is required. So, so close to that, my next question is to Mr. Sarosh. So basically, this is very similar to the question that I asked to Mr. Praveen. So what livelihood benefits do sanitation workers get from fecal sludge management? So we would like to hear about your perspectives in this regard.
Yeah, Mr. Praveen has already touched upon many of the aspects related to this, but let me. First, let me quote our ex-monitoring expert who once used to contest strongly that the impact of any sanitation improvement has to be on health. So he never used to accept that when we say that, a lot of activities have been done in our projects. When the monitoring and evaluation comes, always there is a contest that health improvement has not been to the expected limit. So there is a problem somewhere. So now, when we talk about sanitation workers, it has become a different problem altogether. The normal sanitation improvement itself is expected to improve health, whereas sanitation workers' health is affected due to these activities, which is improving the sanitation of the overall society. So now we have a real problem coming in, and over and above that, these sanitation workers or the manual scavengers are a non-existent category. Officially there are no figures of manual scavenging, whereas we all know that there has been widespread manual scavenging happening all over. So to address something which is not there, visibly not there, is another problem. And coming to the impact of manual scavenging in relation to fecal sludge and septage management, when we talk about treatment systems, we always, or the old classification was that there is a physical treatment system, there is a chemical treatment system, and there is a biological treatment system. Similarly, when we say about the impact to this manual scavenging workers, there is a physical impact, there is a chemical impact, and there is a biological impact. Physical impact could be related to when we open the septic tanks, or there is a physical labor involved in it, in removing this heavy slabs of the septic tanks and going into it. And sewer diving is another aspect. These manual scavenging people, or the manual scavengers, they dive into these tanks which are full of the sewage. So that's another problem. So the contact with this sewage creates a biological problem for that. Whereas prior to entering the tank itself, there is gas formation in all these tanks, whether it is manholes or septic tanks. So that creates the chemical problem before entering. So the use of PPEs and other protective devices have already been covered. It has been mentioned by Mr. Praveen. But now when we come to diseases which are caused due to these impacts to these sanitary workers, there are quite a few of them. Toxic gases inhalation creates asphyxiation, or loss of breathlessness, loss of breath, and it can turn very fatal at many times. That is one. Then overall loss of health due to prolonged engagement in this sort of activities with high physical labor content. That's another problem. And there are diseases like cholera, hepatitis, and Wales diseases, maybe like due to animal fecal content coming into these septic tanks. That's another disease which is caused by all of these. So these are all health problems which they face, and their life is ruined in the long term in taking up this engagement. And when we talk about this, there are quite a few innovations that have come up. Automated maintenance devices have already come up, which would help the sanitation workers in many aspects. I mean, apart from our own new incubating Arc Robotics, which has joined our team recently, they are engaging in sewer cleaning or manhole cleaning through a new robotic mechanism. There are established organizations like Solinas, who has been incubated by IIT Chennai, our parent organization. They have a model which is, if I'm not wrong, it is called Homo Sep, and there is this Bandicoot which is widely popular in Kerala also. I mean, all these help these sanitary workers in different aspects. Like, one, they don't need to do this physical labor of entering into these septic systems, while it helps in their livelihood aspect in the way that they can be part of the whole system, wherein they can manage these automated devices, which helps them not lose their livelihood. I mean, they can go into this activity and do it in a more dignified way, whereas they gain time in terms of doing multiple installations or multiple units at one point of time, which creates more income to them, and that's a source of livelihood improvement to them. Over and above this, there are several CSR funds which are funding for transferring this capital, or rather transferring these mechanisms to the sanitary workers by utilizing these CSR funds. So it gives, those workers who are getting benefited by these sort of activities gets an entrepreneurial stint in their careers, along with some support to bring about change in their lives. With this, I close my views on this matter.
Thank you, Mr. Sarosh. I like the way that you have correlated this physical, chemical, and biological treatment methods with the sanitation workers. So basically, so even though they have PPT kits or everything and to protect themselves, but it's most of the case it won't work. They will not follow the protocols. But we have to ensure that these protocols they have following and protecting themselves in all this process. So with this all, I would like to conclude today's panel discussions, and before that the panel is open for questions. So the participants are encouraged to ask questions.
Actually, it's not a question, it's you can take it as a suggestion. Actually, this is very good. Now I got up so many problems which I was not aware of previously before coming to this program. So I remember one incident which happened during COVID period. KTU announced one program called Ventilator Challenge, and we also participated in that. And when I participated, I realized nearly that was during the COVID period. That is first lockdown. Okay, but the students came up with so many prototypes. They were able to make prototypes even during that lockdown condition. Even I also made a prototype. I got permission from collector and other things, and we were able to do that one. That was a really very challenging one. What I'm telling is, what I'm suggesting to the government of Kerala such mission is, you can put the problem statement in your website, so that, or you can give it to the universities or organizations like IITs, wherein they can put it in the website. There are, in foreign countries, there are, for example, Idea Connection. And Idea Connection is a website where they don't run an R&D lab or anything. So we come up with a solution, we make a prototype, we give it to them, so they give the prize money for that, if that prototype is acceptable by the industry. So what they do is, once I make a prototype, that prototype may not be a product which can be sellable in the market. So I contact this company people. Or they contact them, or they give that suggestion to the industry people. Say they remold it, or they combinedly get the patent and they come up with a product which may be a suitable solutions. So now, for example, you take BTech projects. The quality of the BTech projects live of the IITs and NITs. If you take for the other university projects, they are not up to the quality. The problem is there, available. Problem statement is there. But these students, they do not know what is the problem is. Even from the academic side, even we don't know what the problem is. So we can come up with some solution. For example, a EOD sensor without using a bacteria. There may be some other parameter, or the nitrogen evolved, or the methane evolved by that particular thing. Maybe a parameter which can be tested in our Global Sanitization Center. IIT will be giving the permission for testing it. So we have a standard. Then we can make a sensor and we can give it. So if we make it, that it may be coming some 10,000 rupees. With that itself, they can make the sensor. When we give it to the company people, they can again remold it and make it in a sellable way. So that is a suggestion where the government can look into that. They can update their website in such a way that they can give a space wherein the students can get into that and they can start doing their projects and other things like that.
Okay, Mr. Raja would like to take up these suggestions and respond to this.
Hi. I just want to tell you that we ran some grand challenges. This is called a grand challenge. So there are two kinds of challenges. One is the grand challenge and the other one is the industrial challenge. So in industry challenge, what happens is a company poses its opportunities or pain points and invite entrepreneurs and academia to come up with answers or solutions, and they fund it, right? You get about 100, maybe even 10 perhaps. You get submissions and 2 or 3 of them gets funded. So between 2007 and 2011, we ran about 40-50 of these programs across India. We had industry participating, and we had IITs participating. We had, one of the things that we need is a collective platform, like what we did with Project in Bangalore. So these kinds of organizations take up these ideas and try to commercialize it. So these things are going on. Now CI has a program called CI Cons, where every week one company member of CI will come out with a set of 4 challenges, and there's an ecosystem group of partners, collaborators, which work with these startups or the submissions and try to commercialize it. We are also been working on that in IT startups and IIT. Some of these things are being done. Thank you.
So actually, sorry for the interruption. Actually, I do understand. See, for example, Smart India Hackathon is there. In all India level, they get the problem statement from the industries and they conduct Smart India Hackathon. But if you see at the end of the day, whether anything has come as a product to solve an issue, like for example, we were discussing from the morning about the sewage treatment plant or BOD identification, something which is a product which is sellable in the market and making money or whatever it is. No, so that is the point what I am trying to tell. So of course there are so many grand challenges are happening, so many things are happening. Even Prabhaav, grand challenges is happening now. But the question is whether the output of that Smart India Hackathon, for example, you take it's an all India level event. Hackathon is an all India level event. Whether any tie has come out of that hackathon into the market for my kid to play, that is not happening. Because there is a gap. The industrial and institute interaction is not happening in a real way with the government. That's what is my concern is.
Yeah, your concern is genuine. I want to answer this question because I have been associating with the innovation and hackathon in between for quite a long time, from 2010-12 period when I was working in Water Authority. What Raja has pointed out, that there should be a system to take these things, first thing. Then there should be a governance structure and monitoring to monitor. because what I feel is that why I took the mic, because I had sir has mentioned that Bandicoot system. Actually, it was Kerala Startup Mission was provided the initial assistance for developing the prototype and all those things. After that, it became stuck that they didn't have the fund to test actual product in the field. So at that time, Water Authority has a morning Venkateshwar or some kind of 10% adaptive research, something like that. That fund, normally what happens in the government sector is that if the product fails, it becomes an audit objection and all those things. So because we had a flexibility on that aspect, we invited several people for a challenge. At that time, 4 or 5 people came, and it was the only one idea. This Bandicoot was the only idea worth practicing. So they come up. What happens, because sometimes it happens because in between some demotivating things will happen. I will tell, because this Bandicoot, when it was tested, they tested it prior to making the prototype. They tested in some limited trials in the actual field. But there the manhole size was something like rectangular. The hole was exactly in the middle and all those things. When it came to the actual field, I mean the regular practice in field wherein the manually people were cleaning, the manhole size, sometimes it will be round, the size will be odd, the hole will be eccentric. And the product which they made by around 13 lakhs or 12 lakhs they took and made, it burned out, short circuiting because on the trial. So if they become demotivated and they're dropped back, then this success should have been not there. So what happened to other people means I'm not discouraging them, but sometimes I feel that they just make the things for selling to some private company. It is not out of real interest they are making. Only few. One is that the atmosphere, what is it? Is that the atmosphere is not, now the atmosphere is slowly changing, because as you know, the Government of India projects like SBM, it is not framed on the normal mold in which the government schemes are on. There is much scope for innovation. Even in Amrit it is there. In Kerala also the KDISC is promoting one local body, one idea. So now there is enough scope and funding for actual field trials. But one thing is that the government sector people or the ultimate users, maybe I will say the local self-government department, they have to use this and they have to handhold these people. That gap is always there. I think institutions get IIT, because there is no control mechanism. We don't know whether the product is, we don't have time and money to spend for that thing. That's the frankly speaking. So people doesn't take that risk in the government sector. They will say, if you avoid them, it will be easy. So there should be, if there is some kind of a monetary mechanism, so there's some certification mechanism, after some preliminary screening, IIT says that this is the product worth testing in the field, then the government people will come forward. I think these kind of meetings will form such a platform for this, filling the gap. Then this will come. Otherwise the product will be, the idea will be lost in between.
I'd like to come in here. Global Sanitation Center of Excellence was created for this sole purpose. So we have those 4 stages which will help the idea to go from lab to field testing to scale manufacturing, be tested and certified, and include standards. We have a standards committee that's been formed by the Governing Council, and we're looking into the gaps in the standards. For example, you mentioned septage, as well as solid waste, fecal waste. There are lots of people just discharging it into the fields as manure. So is there, should there be standards for that as well, so that we reduce the helminth level or the bacterial overload or any other toxic substance. So the entire chain with which it has been set up is to handhold people. We have collaboration with government, local bodies, NGOs to help monitor and see that it reaches that level of scale as well as compliance to the standards. That's the vision with which it has been established, and we are getting enough funding to go to the last mile as well. And there's a lot of CSR that is willing to fund them even for initial sales of those gadgets to the ULBs. ULBs have some funding to buy, but there is a gap again in the sale price and the buying price. So that also the CSR is willing to address. So if that answers a lot of your questions, but startup is not for the faint-hearted. It's a long journey. You have to start with customer survey, understand the actual need in each and every situation before you go forward with a product. And in this case especially, one size does not fit all, like all the panelists have been saying. So you have to be very careful of what you're trying to fit in which customer segment. That I think your team has attended GDC, same with Arjit's team. So we have a program where you are forced to go for 2 months and interview customers till you realize what is your customer segment, what is the value proposition for each of those segments. Once you have that mapping, it's a little better to deploy your product to the right fit, product solution fit as well as product market fit. So I'll leave it there.
So yeah, so thank you. So basically we need to conclude it, and with the concluding remarks. So what we can realize that right now, these all are like an ecosystem, and we have technologies, we have innovations, but what would be the demand? That is something like we have to look for. So the technologies that we are developing should be the demand-driven technologies. So as already Mr. Praveen mentioned that the government is promoting on-site waste septage managements, but the technology part is still lagging. So even though technologies are available, but there are some constraints that it will only focus on the liquid part, not for the solid part. And also Mr. Raja has mentioned that when you have innovations, we have to clearly see what are the barriers associated with those technologies. So the technology should be technically feasible, at the same time economically viable, and it has to be scaled up, and it has to be suitable for all the environments. So we may have to implement this technology in some other places, but may not be suitable for other places. So this is a challenge that we are facing currently, and this is a great platform. This platform GSEOE what Tekin has providing is this is just like a meeting of various stakeholders. They can talk about their problems, and the innovators can develop the technologies accordingly. And so with this, I would like to conclude today's panel discussions, and thank you very much for the participants and the panel members, and thank you for GSEOE for this opportunity. Thank you.
Thank you very much, panel members, for the very insightful session. You have enriched our knowledge on sanitation from policy to implementation, and a whole gamut of nuances in between. I would like to request Dr. Sunita to hand over the memento to Raja Rajiv Kumar. Thank you, ma'am. Thank you, sir. I would like to invite Ms. Anuradha Shankar to hand over the memento to Mr. Praveen. Thank you, ma'am. Thank you, sir. I would like to invite Dr. Sudha Vishnudas to hand over the memento to Thank you, ma'am. Thank you, sir. We would like to go for a short break. Sorry, I would like to invite Ms. Anuradha Shankar to hand over the memento to Dr. Sunita. Thank you, ma'am. We would like to go for a short break, requesting all the dignitaries and participants to join us for lunch. Thank Thank you.
It's at the back of the hall.
We would like to start with the idea pitch presentation. I would like to invite Team Aquashore to give their presentation. The team is led by Maria Shaiju of Sahridaya Engineering College. Team, you will have exactly 8 minutes to present and the jury will be giving you the comments. Hello.
Hello everyone, myself Maria Shaju and we are from Sahridaya Engineering College and Technology, and my team members are Henvin Joy, Granat Paul Rafael and Amal TA, and we are from Electronics and Communication Department. Okay, we are introducing a new product to the market called Aquashore, a daily water quality check at home. So, we all know that we daily using water for drinking, bathing, cleaning, etc. But we actually do not know the quality of water we are daily using. So our product coming with a solution to this. So our product Aquashore daily check the quality of water and give message to the user if the water quality is less than the threshold value. Also, it is a completely portable device with a built-in automatic pumping system. So the problem statement. We clean the tank at home once in a year, and this problem to many waterborne diseases like typhoid, cholera, etc. So it is a high time to implement a system to check the water quality daily. So also the main disadvantage, traditional approaches of measuring water is collecting the water from home and giving to the laboratory, and it takes 3 to 4 days maximum. So coming to the solution, our product is a low cost product. So it is a portable device which can be connected to tank easily, and there will be companion app. It will give message to the user. So the advantages and competitive study is say by Henvin. I welcome Henvin.
Okay, as the advantage, our product Aquashore will give correct level of purity of the water we daily use. It is a completely portable device. Monitoring can be done over a very long distance. It is based on IoT, so we can monitor it in every part of the world. We made a companion app to monitor the readings of the sensors. No more water-related health issues. And monitoring is very simple. Fully automated systems avoids the need of human intervention. Continuous remote monitoring is also possible. As the competitive study, we found different kinds of products in the market, but they are not used for as a daily monitoring. Ours is a portable device. Also, there is no automatic pumping system available according to the quality of the water. As the flow chart, this is our flow chart. First of all, we will check the quality and quantity of the water. If the quantity of the water is less than 5% and the quality of the water is good, it will enable auto pumping. And if the quality is bad and the quantity is greater than 95%, it will stop pumping. If the quality of water is poor, it will automatically send a mail to the owner, and it will also display it on the app we have made. So that's the overall working of our product.
This is our block diagram. I will give a brief working of our product. We use sensors such as pH sensor, turbidity sensor, and ultrasound sensor. The values of the sensors are sent to the microcontroller called NodeMCU and DigiSpark. These values are processed and sent to cloud using Wi-Fi. If according to the values of the sensors, the quantity and quality of the water is sensed, and if the water is impure, a mail is sent to the customer, and it can help the customers to know the quality of the water. If the water is poor, it enables the auto pumping and water is pumped to the tank. This is our product design, and the front view and top view. This is our current prototype. Our product is placed on the top of the tank. These are the outputs of the LCD display. This is the app interfacing, the companion app that we are made. This is the output that is sent to the customer. If water is in poor, and notification is reached as to the mail.
Now coming to the future scope, currently we are using turbidity sensor, pH sensor and methane sensor, and in future we are planning to use other sensors like nitrate, arsenic sensor and chloride sensor, and we can add the automatic cleaning systems in our project. Okay. These are the fund breakups of our project. Thank
you, team, for the presentation. I would like to request the jury to give the comments. Sir. I would like to request Mr. Praveen sir to give the comments for the team.
How you selected the parameters turbidity, pH and methane? From what basis? What is the basis for these three parameters determine the quality of water?
No, that is not the parameter to determine the quality of water, but those are the sensors that were readily available for us. So for a prototype, we use that sensors to make.
So methane, how it is related to water quality?
If the bacteria growth is more, it will be, or any kind of sewage in the water can create methane content in water.
The sensor, you have shown that the sensor is placed in a very awkward mode. The tank lid could not be closed. That itself creates an...
It is actually a prototype. Actually in a design...
How you are planning in the...
We are trying to make it in a circular manner so that it will not be opened. The sensors will be dipped directly into the water, and methane sensor and ultrasonic sensor will be stayed on the top of the tank.
What is the USP of your USP in the sense unique selling proposition? There are already products you have shown, but what is your uniqueness in this pH turbidity? Every sensors are available, no?
Yeah.
What is your unique contribution or
actually
innovation?
They are separate sensors, so we club them all.
You are integrated.
Yes, we club them all, and we could use that to daily monitor the water 24/7.
Okay. How you are mailing it? What is the protocol you are using for mailing?
We use an IEEE platform to mail.
Automatically
it will mail.
How much interval?
If the quality of the water is too poor, it will mail 2 mails to the customer, so that if one didn't shown, a second will be.
Why you preferred email over SMS? SMS is an easier option, no?
No, SMS, there were some more extra things to do to make SMS. Email will be, email was more comfortable.
It's automatic email, no?
Yeah, automatic.
SMS is not easy.
Yes, it is possible, but.
Okay.
Okay, now my question is, you are placing the sensor at the top of the tank, is that right?
Only ultrasonic and methane is placed at the top. Others, all sensors are dipped in the water.
Dip in the water means it is measured completely, or it will be at the top. How do we that? When you dip it in the water, it will be at the bottom?
At the bottom.
The sensor, or at the top?
At the bottom.
Okay, so what is the level of turbidity that you are measuring here? I mean, what is the benchmark that, turbidity you are...
We have mentioned it as a clarity of water. If the clarity of water is more than 95%, it is good. Otherwise...
So do you know the standards, the drinking standards of turbidity?
No, standards we have...
But you have to look into the BIS standards, because then only we can say that the water is potable or not. Okay, and there are many constituencies in the water. So not only that pH or turbidity, there may not be, even pHs even go down or high may not cause that much health effects. You have to look into the TDS part, total dissolved solids of the water. Have you looked into that? Since these sensors are readily available, it doesn't matter that when you integrate it into systems that can be portable to the that can make the water portable. No, it's not like that. You have to find out the crucial parameters that is required for
we
the.
are in research to check more number of sensors, to include more number of sensors so that the value will be more precise, the quality will be.
How do you check the precision of your sensor?
Precision of sensor.
Yes.
We will calibrate it with the different.
How do you calibrate it?
If for pH sensor, we will use some pH liquids with pH level, and we'll dip the liquids with pH meter into the liquids and we'll check.
You are continuously keeping the pH inside the water, right? So
Yes.
in the long term operation part, have you looked into that?
After 1 month or twice a week, we will go and give a service to check the sensors.
But that is also very important. Okay, yeah. So these are some of the suggestions I want to mention.
I have one basic question. What water are you testing? What is this water going to be used for?
For drinking and for
Drinking.
household uses. Yes.
And so all these sensors dipping into that water, would I want to drink that water which has those sensors dipping into it?
No, sensors has nothing bad in it.
Whoa, okay. I think you should read up what the sensor is going to, if it's going to sit there in the water for a long time, you're saying the water's pH or turbidity, you do not know. What are the reactions of that sensor itself with that water? Lot of research to be done. And who are you planning to sell it to? Who are your customers?
Domestic households and big water tanks, tea water tanks.
Okay, and you talked about every 15 days there is some service. Who's going to provide the service?
We are actually in a plan for that.
Pardon?
We are actually planning how to do that.
Oh, okay, okay.
Okay, I don't want to drag you, but I'll have the basic things. Number one, where did you get this idea from? Why did you do this project?
Actually, in our home there was an incident. My tank got bad, but we didn't know. After we using for several days only, we could understand that water was bad. So
Okay.
we thought of it as an idea to implement.
And you got your friends too.
Yes.
Good. Now let me ask you a question. Right, you can go back on your presentation if you want. What is the idea that you're trying to sell us?
To check the quality of water and to ensure that good quality water is drinking.
But there are thousands of other ventures across the world. And number two, none of these things are made by you. You are sourcing it from the market. Nothing is yours. What is yours?
We implemented all it together.
No, that is not the thing. Let me tell you what an idea means, right? An idea means that you have something to solve either an opportunity or a challenge, bottleneck, a threat, or something else. That's an idea, right? How you do an idea is a different thing, right? So I could define this idea as, I want to create a product and a service that will enable people to have real-time information on the quality of water or liquid. It just doesn't have to be water. It could be anything else, right? Because sensors are not yours. It's available in the market, or you could outsource it, or you could develop sensors yourself, right? But the whole idea is that the whole mechanism, the product, right? Now you need to define the product. If you don't define the product and the idea properly, your pitch crumbles. Because that is the core essence of your pitch, right? This comes out to me as a school project or a college project, not a venture idea. There's a difference between those two. Okay? So I'm not going into any of the other aspects because I understand that you have no guidance. I mean, Technic is basically there to give you guide if you're selected, but the thing is you don't have any guidance. So number one, do you have a good idea? You need to validate it. You need to ask 10, 20 different people. Suppose I give you a sensor which will transmit real-time quality of the liquid, and I give you a mobile app. Will you buy it? If so, how you need it? Because you need to design the product to fit various containers. So how big is your sensor?
Sensors are
Not. I know how big are sensors. How big is your sensor?
some every sensor
Specifications, dimensions. Dimensions.
Actually, this much size is
That's too big. I've seen sensors which are like this big, which transmit real time. There'll be a transmitter device somewhere, but it has about at least 10 meter. No, that's small size. Those are available. You just need to calibrate it. That's all, right? The second question is, why do you think you're qualified, or why do you think you have to do this project? You're a college student. You don't have technical expertise, right? You have absolutely zero market understanding. So in your presentation, you need to convince us that we should support you, we should back you. You can start by saying your story. My house, my tanker. We came to know only after 2 weeks that a rat died of it. Nobody looks into the tanker, right? So that thought of, see, I'm an affected party, so I have that inspiration and determination to do this job. So you should support me, and I'm learning engineering. This execution is there. I got a good team. Right? She is good for that. He is good for that. He is good for that. So that's how you need to present, right? For me, it's not convincing enough. You're an engineer. I'm sure you will be able to make a product in your lab. It's not difficult, but you need to understand what it is. So as Madam said, you need to do research. You need to look at who are the competitors. One of our Andy is there, Google Andy. You can just ask her. Now chat GPT is also there. You can ask. Give you everything. You even have blueprint of this product. Now, there are lots of products out in the market where you can get it on the mobile phone, on an Apple Watch. You get SMS, you get real time. There's a dashboard with real time information on the content. As you said, everything depends on the sensor. You calibrate the sensor, you get the right sensor, it can give you any information. But the idea here is that you should first understand what your idea is. Okay. And then you should be able to articulate it. Right? See, nobody is born with all this ability. You learn it on your way. Right? So, can you tell me once again, what is your idea? If you don't want to speak in English, you can speak in Malayalam also, no problem. But try to, even if you make some mistakes, no problem. 30 seconds, please. വേണമെങ്കിൽ 1 മിനിറ്റ് ആലോചിച്ചിട്ടാണെങ്കിലും കുഴപ്പമില്ല. But explain in 30 seconds. You don't have to say, anyone can say it.
ഓക്കെ, അപ്പോൾ ഞങ്ങളുടെ പ്രൊജക്റ്റ് എന്ന് പറയുന്നത് അക്വാഷുവർ. ഇപ്പോൾ ഈ ഒരു ഐഡിയ ഞങ്ങൾക്ക് വരുന്നത് എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ, എൻ്റെ വീട്ടിൽ എൻ്റെ അമ്മ എപ്പോഴും പറയാറുണ്ട്, ടാങ്ക് ക്ലീൻ ചെയ്യണം എന്ന് പറയാറുണ്ട്. അപ്പോൾ അപ്പോഴാണ് ഞങ്ങളത് SM-ൽ ചെയ്ത പ്രൊജക്റ്റാണ്. ഇപ്പോൾ ഞങ്ങൾ ഫൈനൽ ഇയേഴ്സ് ആണ്. S6-ൽ ചെയ്ത പ്രൊജക്റ്റാണ്, മിനി പ്രൊജക്റ്റാണിത്. അപ്പോൾ ഞങ്ങളിങ്ങനെ ആലോചിച്ചു ഏത് ഐഡിയ ആണ് ഞങ്ങൾക്ക് കൊടുക്കണ്ടേ എന്ന് ആലോചിച്ചപ്പോൾ സാറ് പറഞ്ഞു, നമ്മളിപ്പോൾ നേരിടുന്ന പ്രശ്നങ്ങൾക്കുള്ള സൊല്യൂഷനാണ് നമ്മൾ ആദ്യം കണ്ടുപിടിക്കേണ്ടത്. ആദ്യം നിങ്ങൾ കണ്ടുപിടിക്കേണ്ടത് പ്രശ്നങ്ങളാണ്, അതിൻ്റെ സൊല്യൂഷനാണ് നിങ്ങളുടെ പ്രൊഡക്റ്റ് എന്ന് പറയുന്നത്. അപ്പോൾ ഞങ്ങളതിൽ ആലോചിച്ചപ്പോൾ അമ്മ ഇങ്ങനെ പറയാറുണ്ട്, മുകളിൽ പോയി നോക്കിയോളോ, വാട്ടർ ടാങ്ക് ക്ലീൻ ആണോ നോക്കാൻ പറയും. അപ്പോൾ നോക്കിയപ്പോൾ ഭയങ്കര നമുക്കറിയുന്നില്ല, നമ്മൾ ഒരു സമയത്ത് പറഞ്ഞ് നോക്കാൻ പറഞ്ഞു, നമ്മൾ നോക്കിയില്ല. അങ്ങനെ വർഷങ്ങൾ, ഇപ്പോൾ ഒരു വർഷത്തിൽ ഒരിക്കലൊക്കെയാണ് നമ്മൾ നോക്കുള്ളൂ വാട്ടർ ടാങ്ക് പോയി നോക്കാമെന്ന് പറയുന്നത്. മുതിർന്നവരെ സംബന്ധിച്ചോളം ഇപ്പോൾ വീട്ടിൽ വയസ്സായവരൊക്കെ ഉണ്ടെങ്കിൽ ടാങ്കിൽ പോയി നോക്കാമെന്ന് പറയുന്നത് വളരെ ബുദ്ധിമുട്ടുള്ള കാര്യമാണ്. എല്ലാവരും ഇപ്പോൾ കുട്ടികൾക്കൊന്നും പോയി നോക്കാൻ ബുദ്ധിമുട്ടില്ലെങ്കിലും പാരൻസിനൊക്കെ അവിടെ പോയി നോക്കി വാട്ടർ ടാങ്ക് എല്ലാ ദിവസവും ക്ലീൻ ആണോ നോക്കാൻ ബുദ്ധിമുട്ടാണ്. അപ്പോൾ അതിന് വേണ്ടിയിട്ട് ആണ് ഞങ്ങൾ ഈ ഒരു ഐഡിയ കണ്ടുപിടിച്ചത്. ഇപ്പോൾ ഈ ഒരു അക്വാഷൂർ നമ്മുടെ വീട്ടിൽ യൂസ് ചെയ്യുകയാണെങ്കിൽ നമുക്ക് ഡെയിലി പോയിട്ട് എൻ്റെ വാട്ടർ ടാങ്ക് ക്ലീൻ ആണോ നോക്കേണ്ട ആവശ്യമില്ല. ജസ്റ്റ് മൊബൈലിൽ ഫോണിൽ നമുക്ക് മെസ്സേജ് വരും, എപ്പോൾ വാട്ടറിൻ്റെ ക്വാളിറ്റി കുറവാകും, ഒരു ലിമിറ്റ് വെച്ചിട്ടുണ്ട്, ആ ലിമിറ്റിനേക്കാൾ കുറവാണെങ്കിൽ നമുക്ക് മെസ്സേജ് വരും. അപ്പോൾ അങ്ങനെ നമ്മുടെ മാർക്കറ്റിൽ കുറേ സെൻസേഴ്സ് ഉണ്ട് വാട്ടർ ക്വാളിറ്റി ചെക്ക് ചെയ്യാനായിട്ട്. ഇപ്പോൾ ഞങ്ങൾ പറഞ്ഞ ഈ pH ടെർബിഡിറ്റി മാത്രമല്ല വാട്ടറിൻ്റെ ക്വാളിറ്റി ചെക്ക് ചെയ്യാനുള്ളത്, കുറേ പാരാമീറ്റേഴ്സ് ഉണ്ട്. അപ്പോൾ ഞങ്ങളുടെ ലാബിൽ ഞങ്ങൾക്ക് അവൈലബിൾ ആയിട്ടുള്ള കുറച്ച് സെൻസേഴ്സ് ഉപയോഗിച്ചിട്ടാണ് ഈ ഒരു പ്രൊജക്റ്റ് ഞങ്ങൾ ചെയ്തത്. ഇപ്പോൾ നമ്മൾ pH നമുക്കറിയാം, ഒരു ന്യൂട്രൽ എന്ന് പറഞ്ഞാൽ 7 നിൽക്കണം, 7 കുറവാണെങ്കിൽ ആസിഡും 7 കൂടുതലാണെങ്കിൽ ആൽക്കലി, ആ നോളേജ്. അപ്പോൾ ബയോമെഡിക്കലായിട്ട് ഞങ്ങൾക്ക് അത്ര നോളേജ് ഇല്ല, ഞങ്ങൾ ഈസി സ്റ്റുഡൻസ് ആണ്. അപ്പോൾ അതിൽ നിന്ന് കണ്ടുപിടിച്ച ഇപ്പോൾ pH സെൻസർ യൂസ് ചെയ്തു, ലാബിൽ നിന്ന് അടുത്ത ടെർബിഡിറ്റി കിട്ടി, ക്ലാരിറ്റി ഒക്കെ നോക്കാനായിട്ട്, എത്രത്തോളം ക്ലൗഡ്നെസ് ഉണ്ട്, വെള്ളത്തിൻ്റെ ക്വാളിറ്റി ചെക്ക് ചെയ്യാനായിട്ട്, പിന്നെ വെള്ളത്തിൻ്റെ ലെവൽ. ഇപ്പോൾ വാട്ടർ ടാങ്കിൽ വെള്ളം നിറയുകയാണെങ്കിൽ ഓട്ടോമാറ്റിക്കായിട്ട്, ഇപ്പോൾ നമ്മുടെ പല വീട്ടിലുണ്ടാവും വാട്ടർ ടാങ്ക് നിറഞ്ഞു പോവും, ആൾക്കാർ ശ്രദ്ധിക്കാണ്ട് വെള്ളം പോകുന്ന സാഹചര്യമൊക്കെ ഉണ്ടാവും. അപ്പോൾ ഈ ഒരു പ്രൊഡക്റ്റ് യൂസ് ചെയ്യുകയാണെങ്കിൽ അതിനും നിങ്ങൾക്ക് ആവശ്യമില്ല, നമ്മൾ ഓട്ടോമാറ്റിക്കായി നമ്മൾ പോയി ഓഫ് ചെയ്യേണ്ട ആവശ്യമില്ല, ഓട്ടോമാറ്റിക്കായിട്ട് നമ്മുടെ ഈ സിസ്റ്റം തന്നെ ഓഫ് ചെയ്യും. ഒരു 95% വാട്ടർ ടാങ്ക് നിറയുകയാണെങ്കിൽ നമ്മുടെ ഈ സിസ്റ്റം തന്നെ അത് ഓഫ് ആക്കും. അപ്പോൾ അങ്ങനെയാണ് ഈ സെൻസേഴ്സൊക്കെ. അപ്പോൾ നമുക്ക് pH വേണമെങ്കിൽ യൂസ് ചെയ്യാം സെപ്പറേറ്റ്ലി, അല്ലെങ്കിൽ ടെർബിഡിറ്റി യൂസ് ചെയ്യാം. അപ്പോൾ ഞങ്ങൾ എന്ത് ചെയ്തു, ഞങ്ങളെല്ലാം ഈ സെൻസേഴ്സിനെ കമ്പൈൻ ചെയ്തിട്ടാണ് ഈ അക്വാഷൂർ എന്ന് പറഞ്ഞൊരു പ്രൊഡക്റ്റ് ഇറക്കിയത്. അപ്പോൾ ഇതെന്ന് പറഞ്ഞാൽ ഏറ്റവും കൂടുതൽ യൂസ്ഫുൾ ആയിട്ടുള്ളത് ഈ എൽഡേൾ, ഇപ്പോൾ വീട്ടിൽ മക്കളൊക്കെ വിദേശത്തായിരിക്കും, അവർക്കൊക്കെ പോയി നോക്കാമെന്ന് പറയുന്നത് ബുദ്ധിമുട്ടാണ്. അപ്പോൾ ഫോണിൽ ഇപ്പോൾ എല്ലാവരും, ഇപ്പോൾ സാറ് പറഞ്ഞു SMS അല്ല ഇതിനേക്കാൾ നല്ലത് ചെയ്യാൻ പറ്റും. അപ്പോൾ ഞങ്ങളുടെ ആ സമയത്ത് ഞങ്ങൾക്ക് ഇമെയിൽ വെച്ച് ചെയ്തപ്പോൾ പെട്ടെന്ന് പ്രൊജക്റ്റ് നമുക്ക് ഔട്ട്പുട്ട് കാണിക്കണമല്ലോ. അപ്പോൾ ഇമെയിൽ വെച്ച് ചെയ്തപ്പോഴാണ്, ക്ലൗഡ് സിസ്റ്റം വഴി ചെയ്തപ്പോഴാണെങ്കിൽ പെട്ടെന്ന് ഔട്ട്പുട്ട് കിട്ടി. അപ്പോൾ ഈ ഒരു S6 ഒരു മിനി പ്രൊജക്റ്റ് എന്ന നിലയിൽ ഞങ്ങൾക്ക് കുറേ സ്ഥലത്തുനിന്ന് സെലക്ഷനും കിട്ടി ഈ പ്രൊജക്റ്റിന്. കാരണം നമുക്ക് ബുദ്ധിമുട്ടാണ് ഈ ഒരു ടാങ്കിൽ പോയി നോക്കാമെന്ന് പറയുന്നത്. അപ്പോൾ ഇതാണ് മെയിൻലി ഞങ്ങളുടെ ഐഡിയ എന്ന് പറയുന്നത്. അപ്പോൾ ഇതിൽ ഞങ്ങൾ ചെയ്ത ഐഡിയ എന്ന് പറയുന്നത് എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ, ഞങ്ങളുടെ ഭാഗം എന്ന് പറയുന്നത് മാർക്കറ്റിൽ സെൻസേഴ്സ് ഉണ്ട്, പലതരത്തിലുള്ള സെൻസേഴ്സ് ഉണ്ട്. അപ്പോൾ ഞങ്ങളെന്ത് ചെയ്തു, ഇതിനെല്ലാം കൂടി ഇൻ്റഗ്രേറ്റ് ചെയ്തിട്ട് ഒരു പ്രൊഡക്റ്റ്, സെൻസസ് ഞങ്ങൾ ഉണ്ടാക്കിയതല്ല, സെൻസസ് ഓൾറെഡി അവൈലബിൾ ആണ്. ആ സെൻസസ് ഒക്കെ വെച്ച് ഇപ്പോൾ ഞങ്ങളുടെ കയ്യിലുള്ളത് ടെർബിഡിറ്റി, അതുപോലെ തന്നെ pH, അൾട്രാസോണിക്, വെള്ളത്തിൻ്റെ ലെവൽ ചെക്ക് ചെയ്യാനുള്ള സെൻസർ, ഇതൊക്കെ വെച്ചിട്ട് ഒരു കമ്പൈൻഡ്, ഒരു ഇൻ്റഗ്രേറ്റഡ് സിസ്റ്റം, മാർക്കറ്റിൽ സെപ്പറേറ്റ് ആയിട്ട് ഇരിക്കുന്ന ഈ സെൻസസിനെ ഒരുമിച്ച് കമ്പൈൻ ചെയ്ത് ഇൻ്റഗ്രേറ്റഡ് ആയിട്ട് ഒരു സിസ്റ്റം ഇറക്കി. അതാണ് അക്വാഷൂർ. താങ്ക് യു സർ.
ഒരു കമൻറ്റും കൂടെ, അതായത് ഇപ്പോൾ നിങ്ങൾ പറഞ്ഞ പകുതി ഐഡിയ മാത്രമേ ഉള്ളൂ. ഐഡിയ അത് കംപ്ലീറ്റ് ആകണമെങ്കിൽ യു നീഡ് ടു ഹാവ് എൻ എക്സിക്യൂഷൻ സ്ട്രാറ്റജി, ബിസിനസ് സ്ട്രാറ്റജി, മാർക്കറ്റിലേക്ക് എത്തുന്ന സ്ട്രാറ്റജി, ഓക്കെ, സർവീസ് ചെയ്യുന്ന സ്ട്രാറ്റജി ആൻഡ് എ റോഡ് മാപ്പ്. ഇതെല്ലാം കൂടെ ചേരുന്നതാണ് ഐഡിയ എന്ന് പറയുന്നത്. ഓക്കെ, സോ നൗ യു ഗോട്ട് ഹാഫ് ഓഫ് ഇറ്റ്, റൈറ്റ്? സോ ദാറ്റ്സ് ഇറ്റ്. താങ്ക് യു വെരി മച്ച്.
താങ്ക് യു സർ.
Thank you, Team Aquashore. Next, we will have Tech-in Incubative presentations. I would like to call our pre-incubative team, IND Classic, led by Dr. Sambat Kumar and team for their presentation. Over to you.
Okay, good afternoon, everybody. Actually, we are getting pre-incubated in IIT Palakkad under Tech-in. Actually, this started, my father is a diabetic, and he used to use Indian toilet, and he was used to Indian toilet, and at one stage he was not able to sit and get up from the Indian toilet, the squatting position, he was not able to get up. So there was a problem, and what we used to do is, after pottying, we used to get him up from the toilets. Then we asked him to use Western toilet, but he was not comfortable in using Western toilet. At the time I was searching for some solution. At the time I came across Samasta 2.0. Then, because there was no solution available for Indian toilet, there was no research done on Indian toilets, and no product was not made for supporting people who are using Indian toilet. So what I did was I came up with an product for my father, that is an hydraulic seat riser for Indian toilet, so that you can slow it down and you will get an Indian squatting position. Then when you want to get up, it will rise up. They can get into the Indian, the Western closest style, and they can come out of it. And with that idea, we pitched in for the semester 2.0, and we got selected for getting pre-incubated. Then IIT Palakkad suggested, the Tekin team suggested to go us for a training, because we are an academician and we don't have any idea about the business and how to sell it or how to make it, whether that product is a market fit product or not. So we went for a training in IIT Madras GDC program. That's an 8-week training program. There we understood that an Indian toilet market is a shrinking market, and people are just getting converted themselves to Western toilets. And so what we thought is, why don't we make something for Western toilet? Even elderly people find difficult to get up from Western toilet, and there are so many difficulties in using a Western toilet. And we made a customer survey and customer reviews. So these are our learnings from our interviews. We interviewed around 91 persons. In that, 55 were using, were having only Indian toilet, and in that case only 18 were using what we called 18 were using what we called the Indian toilet, and 36 houses they were not having that facility, and 35 out of 91 are using walking support, and 20 need support person help for cleaning or moving inside the toilet, and 5 they cannot even walk, and 3 are bedridden, and 32 they don't need any support, they are happy with what they are having in existence, and 42 felt difficulty to bend the legs, and 41 are having knee problems. And all of them were aware of the Indian squatting position, the benefits of the Indian squatting position, all these things were aware, but due to their medical conditions they were not able to use, and 45 out of 91 were having defection problem. In that case we made an analysis, and secondary research we found nearly 22% of the Indian population is having constipation issues. And 3 customers they wanted a cushion setup because they were having numbness, experiencing numbness, and 8 out of 91 are differently abled, and they don't need separate because support because they were used to that conditions, and 3 were having fear of using Indian toilet. So this is the conclusion that what we have made from the customer interview, that is the maintaining good hygienic practice, that is by self cleaning, that is independent cleaning by the elderly people was the most essential thing, and everybody were knowing about the squatting position benefits and other things. And the customers, if you say for example an elderly customer or a disabled person, they need support right from the toilet door to toilet and again back to the toilet door. So this is what we got the thing. And why we have choose this washing as a main important parameter is because when a customer enters into a toilet, see in the Indian cleaning system is completely different, and Western cleaning system is completely different. They use paper, but in Indian system they use water to clean. So our problem statement is completely different from that of the other countries' problem statement. So a customer entering into a toilet, he needs a person support to reach the toilet, and then he need to position himself, and customer is pottying and is not able to wash on their own, then need help to move out. Okay, in this case if it is yes, then there is no problem, but in this case if anything is no, that is a problem. In that no problem, if you see, that is they are not able to wash on their own, it is a discomfort situation where for both the customer as well as the supporting person it is a discomfortable position. So an optimal technical solution is needed for that, and so we came up with a 3-in-1 stool called co-walker chair, which is a walker, a toilet stool. At the same time, it is a chair, it can be used as a chair, and this is useful for the elderly people to maintain the hygiene and balance. And this is the first prototype which we have made, and I'll show a video that will demonstrate that function. No. Ah, yes.
Elderly people who are not able to wash on their own or who are not able to balance in the toilet and wash. So here this is a very simple setup. It should be like this. Here we use the toilet. Then we use the toilet like this. And then after completion of the process, they simply lift their body and they can fix this one. And now they can sit over here and they can wash. So that they can use both hands on the boiling water and other one. And if we have a widget, we will sit here with this same thing where they can very conveniently wash. The hygiene thing can be maintained. Thank you. Premium models here are there. This is one. Best one.
So this is the advanced version which we are right now we are making this prototype, which is an aluminum based one. So this is having a setup like this. So this will be having a setup here. This will be used for them to obtain the squatting position, and at the same time they will not get the numbness. If you are the oldest person sitting for a long time, they will not get numbness or anything. And this is the one which we have explained. And here we will be having a plate which can be used when they are putting that plate, that will become a chair. And here you will have one more support. You can close that one and you can use it as a back of the chair. So this will be used as a walker also. When you remove this thing, and with that support it will be used as a walker. So for example, why we are designed why the chair is because most of the people know, for example, if they are handicapped, if they are moving to a bus stop or something, they don't have a place to sit. And they cannot keep on balancing for a longer time, they can use this as a chair also. They are using the toilet, particularly when they are going for outstation or for using any public toilet or anything. Other time they can have it in a more hygienic way also. Without getting into that toilet seat, because public toilets generally, particularly if you take for a handicapped person or those person, the toilets are not neatly maintained. So they can use this as their toilet and they can clean it and then they can come back. They can use the hand shower and other things and they can conveniently come. And I have one more video which will demonstrate about all our products. Actually, it was played during the lunch break. This is the first product which I made for my father. This one for the knee replacement surgery and other things, they cannot bend one leg. So at the time they cannot keep on potting without bending, so you can use that one. Thank you. Any queries? No questions. Thank you. No, sorry.
There is one issue which I see in this is it's easy for anyone to copy this.
Yes, sir, of course.
That is one thing that you need to keep in mind. Second, what I would suggest is to add some wheels to it.
Sir?
Some wheels to it.
Wheels, yes, sir, but if you're adding a wheel, no, then it becomes more complex.
It
more
doesn't.
slippery,
It doesn't.
Slipperiness.
Because then it becomes more useful. Because I've just come out of this situation, right? 23 years ago, I was bedridden. I was paralyzed. So I personally know how good this is. And just now, last 4 months, there was a member of my family who had a stroke, and he had this problem, right? For at least after 2 months, he was able to get up, but the toilet and all those things, once the tubes and all removed. So a wheelchair which can be modified to do this would be more useful for a lot of people. You have a bigger market.
Sure, sir.
Okay. Design of this, all that is secondary, because the thing is, I would suggest that you engage with somebody from an ID or National Institute of Design or some other, or Srishti.
Actually, we have discussed yesterday with Nish, sir.
Okay.
They agreed to validate this.
Not validate, redesign. Validation is a different thing. Altogether. Yeah, I understand. I'm giving a suggestion.
Yeah, I understand.
So at some point of time, you need to do that. That's all. But I see there's a huge market for this product. Okay, it's such a simple solution. It's a surprise that nobody else has done this. You see, you come across some stuff like this which anyone could have done, but nobody did it. This is not rocket science. It's
Yes,
very
sir.
simple.
Of course, I do agree.
Yeah, but you do this only when it hits you. So you had that experience, so you did that, right? So these are just 2 or 3 things which I have a suggestion. Second and third, you need to create a good business plan. And when you do the business plan, you could look at how to scale it up. Yeah, without your hands getting too much tied up. But this is a good venture, and it is definitely fundable. There are lots of funds which are available for this kind of project. But they need to see a good, proper business plan. I think you just started, so you got a long way to go.
Sure.
But my suggestions. Thank you.
Thank you.
Thank you, Dr. Samrat Kumar, for the wonderful presentation. I would like to invite our incubator team, Pragati Tech, led by Arjit Majumdar, to give his presentation.
Hello. So, hello everyone, myself Arjit Majumdar, founder of startup Pragati Tech. So our vision is to provide an easy and efficient way of sanitization using smart robots. So coming to the problem statement, so here I have mentioned some crucial points regarding the healthcare sector. So you can see like India has overall world's 14% population who is suffering from 50% of all total disease due to poor sanitization. The next point is regarding hospital acquired infection. So this term I'll be using frequently throughout this slide. So this is HAI that regards to hospital acquired infection. So it accounts for 2 million cases every year in India, and that leads to 80,000 deaths in India. So you can imagine like in every hour 10 people getting died due to this hospital acquired infections. So the next point is like 1 out of 10 people got infection cases. Why they are admitting in hospitals? So the next point that is also a crucial point, that lack of compliance of staffs leads to a bacterial growth or chances of infection spreading to 27 to 86%. So like what happens in healthcare sector, so the healthcare workers who working there, so they have to keep on doing their works like every 2 hours or 3 hours repeatedly. So after that what happens, like the efficiency and as well as the effectiveness of sanitization get reduced. And also they came out with the hazardous chemicals like that Shahrukh had mentioned in time of that seminar time. So he mentioned that thing also. So they came in contact of the hazardous chemicals, so that leads to some skin diseases like skin cancer also it can happen. So this is a very crucial point. And the last point is the microbial growth in toilets. So we always think about clean toilets, but we didn't imagine about disinfection of toilets. So this is also very crucial. Like we are repeatedly using the toilets, but we are not cleaning that every time. We are just cleaning it and just leave it. We are not thinking about disinfection. That causes maybe urinary tract infections. So on this point, we have done more research and we have done some secondary research. So from that, we have found this data. Like these are some headlines of news portals, and from that we found like 7 lakh deaths happen every year for these hospital-acquired infections, and also it can grow up to 10 million cases per up to 2050 globally. And also this HAI are alone killing more than the number of cancer as well as plus the traffic accidents. And the last point also, it is like hitting our economy very badly. That point I have also mentioned here in this slide. So the next point, like we are proposing this robot. This is SNH robot. This currently we are developing. We have done the MVP and some initial testing. So this comes with 2 features. One is UV disinfection and the second is a dry misting. In the UV disinfection, we have done initial testing where we have found 2.5 meter effective range of this, and also we are using 254 nanometer wavelength UV light and with 3-hour runtime. And in the case of dry misting, so it will like the particle size is only 10 microns, so it will not wet any surface, but it will sanitize the overall place without any human intervention needed. So we can control it any point of the world. Suppose you are sitting here and the robot is in certain hospital, so you can control it through IoT. So this is the main 2 features. So coming to the, so this is a video. So you can see, so it has a range of up to 10 feet. So that a human reachable height. So it can sanitize up to that. So the next part is the web interface. So we can control this robot from anywhere, from laptop, desktop, any other device you can have on hand. So you can control with that. So this is a basic control page. So this consists with a battery level indicator, real-time visualization of camera, and also you can control the UV misting any point of the world. And also if suppose there is an error or bug happen in this robot, so it will detect in this app interface itself. So the next most important part is the market opportunity. So we have distributed between TAM, SAM and SOM. This is a very general thing regarding the business. So the TAM we have targeted initially like the hospitals. So hospital, there are 2 kind of hospital, private and public. So then from that we choose private hospitals, and from private hospital we have choose 350 plus bed hospitals who have ICU, CCU and emergency unit, because a hospital has a certain guidelines to follow that regularized by government. So that's why our initial market will be like the Kerala and Coimbatore belt. There was around 5,000 to 6,000 hospitals there, and 350 plus bed also. So this is our serviceable obtainable market. So coming to the testing report, so we have done initially testing with few hospitals like Ahelia Hospital and Rajiv Gandhi Hospital. So these are the reports of that. So even this report only provided by the hospital authority itself. So coming to the lab testing report, so this testing we have done in IIT lab itself. So this all we got around 97% of bacterial reduction. We have tested in different conditions, with misting, without misting, with different concentrations, as well as like different height of like 6 feet, 3 feet or ground level. So we have done several testing, so we got around 97% of germ reduction. So this all you can see. So this is our team. Thank you. So
do we have any questions for Ajit? Okay. Thank you, Ajit, for your wonderful presentation.
Let us proceed to our next panel discussion. I would like to wholeheartedly welcome our panelists, Mr. Sri Ganesh V. Nayak, Mr. Shubha Vishnudas and Mr. Vinod Subramanian. The panel would be discussing effluent management and eco restoration. Let's have a brief description about our panelists. Mr. Sri Ganesh B. Nair is the CEO and Chief Consultant of Ganesh Technical Consultancy Services. He is a renowned green building and sustainability expert and building and infrastructure consultant with a BTech with distinction in civil engineering from Kerala University. He has the expertise in understanding wastewater and solid waste treatment solution as a specialist in STP, reforms and rehabilitation services, and is a recipient of various national recognitions like National Energy Award for Innovative Product by CII in 2015, National Recognition for Highest Rated Platinum Green Home by IGBC in 2016, and also the National Recognition for Exemplary Performance in Water Management for GRIHA project in 2017. Welcome you, sir. Our next panelist is Dr. Shubha Vishnudas. Is a full-time professor in the Civil Engineering Department of Cochin University of Science and Technology. She holds a PhD from Delft University of Technology, the Netherlands, and has a master's and bachelor's degree in civil engineering. She has more than 70 publications in international journals and international conferences. She is a member of several professional bodies in India and abroad, had several overseas visits and invited talks. There are 10 PhD scholars working under her guidance in the field of sustainable development. She is also a governing body member of National Choir Research Management Institute, Kerala. Her area of interest include sustainable building materials, sustainable water management, sustainable waste management, house and green building. Welcome you, ma'am. Next in the panel, we have Mr. Vinod Subramaniam. Is the CEO of ERAM Scientific Solutions Private Limited, a R&D social enterprise operating primarily in the water and sanitation sector. ERAM Scientific is also the knowledge partner of Tekin and has introduced India's first electronic public toilet. The revolutionary concept of technology integrated toilets to address the challenges associated with public sanitization in society. Mr. Vinod is a law graduate and has an MBA in business administration and interested in socio-economic development. He has consolidated 100 plus innovations aligned to sustainable development goals and has been a participant in National Visitors Leadership Program Changemakers 2017 by US government. He is currently engaged in setting up world's first sustainable livelihood solution park in Bangalore. Warm welcome you, sir. The panel is moderated by Mr. Praveen Govind, Project Manager, Tekin. Welcome, sir. Over to you, sir.
A very good afternoon to all. So as we are moving into our third panel deliberations for the day, so this panel we would like to discuss about the effluent treatment and eco-restoration aspects. To open up the deliberation, I would like to take a quote. Our ecosystem itself is a permanent and primary economy. So this was stated by Sri Sundarlal Bahuguna, who was a famous environmental campaigner and a leader of Chipko movement. So this itself states that need of eco-restoration and environmental protection activities. So it's a need and it's a very crucial thing that protects not only the ecosystem but also our health and well-being. So the term eco-restoration is generally means that the process of reverting the degradation of the damage that we have already caused to the environment. So in this panel discussion, we would be like to discuss the modalities and innovative scope to how to do about this eco-restoration aspects, especially to discuss about the effluent management technologies and related themes with our eminent panelists. So I'd like to open up your thoughts in 1 or 2 minutes, then we can take up the deliberations in detail. With Dr. Shubha, please, first.
Hello. Yeah. So
So actually, whenever I start discussion with any aspects, what I always start is with about the sustainable development goals, because I feel work in the field of sustainable aspects. And the 12th sustainable development goal always says about responsible consumption and production, which we the human beings are less bothered about. Because whenever we talk about water or waste management or materials that we always look upon, and we always say that if you talk about water, we talk a lot about wastewater treatments. But and also when we talk about water again, then we say that if there is a war comes next, the war will be for water. Actually, what I always feel is like the war is not among the nations or between the, because we always talk about sharing of water or sharing of rivers, likewise what we do, what we see across the world. And I always think upon, we actually have a war between the human and the nature and the agriculture, because we on one side, we in the morning itself we were talking about how we do the treatment processes, but all those times what we say is that the wastewater, the effluent treatment, the STPs, that all focus on the effluent. But on one side we say is about water scarcity, that means we cannot design different things with respect to 135 ml, that is what we always say. But now the literature says, or the studies by UN says, that we have to limit for the precisely what we actually require the water. That comes to be about 50 liters. That comes 5 liter for drinking, then 25 for sanitary, then 15 for bathing, and then the other 10 for the cooking. So we have to limit with the, if we limit it with supply of 50 liters alone, automatically the effluent will be reduced drastically, and which the people can have, the households can treat it themselves. So the eco restoration start from the bottom stage, from the people. That is my perspective.
Mr. Vinod, your thoughts, please.
From the entrepreneur's viewpoint, by hearing all these stories and listening to the UN reports and how the world's move ahead with SDG goals and other things. From the entrepreneur standpoint of view, we make innovations, we work on the technology, then we tried integrating with the community and government. I would like to touch upon how an entrepreneur faces when he is forced to work in this particular segment, and how the other ecosystem react, such as government, community, and other players in the system reacts to when somebody decides to work on a sustainable development or such kind of niche areas. Especially in a situation where we live in a place where the government is omnipresent, government is omnipotent, and government do from poultry development to rocket science, government is there. So in that situation, when as an entrepreneur, when you do something, where you work and how the ecosystem, how the system, and how the practices and rules affect you. That is the point I would like to share some practical difficulties we are facing while implementing these kind of projects. That's my opening remarks.
Mr. Sriknesh, your opening thoughts, please.
Thanks, Praveen. It's quite enlightening to be around all of you. We have spent about 30 years trying to understand what is sustainability. So the simplest definition that we found was, let it be as it is. So, but the way we are moving forward, I think coining complex terms is making it difficult for people to understand what it is. For example, I happen to travel around and deliver trainings for several aspects related to green building, sustainability, energy management, etc. I find that none of the people are able to define sustainability as it is. They give various dictionary meanings. So probably that's one thing we should try to understand first. In piano, there is, if somebody is learning music or piano, there is a key for sustain. Does anybody know that? In music, there is a key for sustain. That sustain, if you keep it switched on, the note sustains. Even when you are teaching children piano notes, either you can have the note ring once and leave, or it stays there. So the word is very simple, and somebody who put that rightly on the keyboard, let it remain there. That's what sustainability tries to convey. And I think eco-restoration is something which sustainability leads to, because air, water and soil, these are the three resources available to us. Every child born, every animal on the planet is given these three things. Fortunately, we use the term animal for those creatures which don't do anything bad. And the developed human beings with far advanced brains have made life miserable for us and them. So restoration of soil is the first challenge that we face as a product of poor sanitation principles. Ernakulam is an example. As the name suggests, it is a column. Of what? It is not a column of water, it is a column of, column is pond in Malayalam. I hope everybody understands Malayalam. Ernakulam is a column of sewage, because a high water table of 60 centimeters to 1 meter below ground ensures that the sewage or septic tank outflow or leaking pipes or all the anomalies in the conveyance systems that we have in terms of sewage transportation all contribute their bit to enriching the septicity of the groundwater in this part of Ernakulam. Now, there is something called Vastu that we look at very carefully nowadays. I find it quite amusing. There are colonies in Ernakulam and suburbs which are the properties are like 2.5 cents, 3 cents, 5 cents, 6 cents, etc. One guy's consultant says that the septic tank and the soak pit should be in the northwest corner. That's probably something which everybody has heard. And he says your well should be in the northeast corner. Fair enough. What about the neighbor? The person just adjacent to this fellow has his well right next to the sewage tank, septic tank. So there has to be common sense which has to prevail. Now I think engineering and knowledge and training and all the schooling that we have should be aimed at discovering common sense a little bit. So conservation is going to be a byproduct of common sense, and restoration will happen the moment we realize what we lost. So I think, Praveen, we can move forward. Thank you.
You rightly pointed out, as you said, about the key of sustenance. So about the green building aspects and the technologies that are meant for the effluent treatment, what is the key for sustaining in terms of the startup perspective? So if you are thinking about anything on the effluent treatment, so what would be the first key of sustenance for them?
Excellent. See, green building is all about, it's a movement which started probably in the 80s in the US, and then it has slowly managed to find a foothold in India in 2000s, and probably India is the first respondent in terms of trying to adhere to sustainability goals, and present administration is trying its level best. And the concept of rating and certifying buildings as green is a tangible method of achieving the goal of what we said or what we set out to, which is eco-restoration. In addition to what Madam said earlier about prudence in choice of consumption, which is the bigger keyword, and then prudence in the choice of utilization, consumption, utilization, and management of waste. These 3 points are actually large opportunities available on the ground for startups. I can tell you at least 1,000 things which are available right under the sky, which have to be done. Like Raja said earlier, it is the most ordinary solution that people are looking for. We are not looking for extraordinary solutions. It is the most ordinary solution. He has developed something which is very ordinary, but that's what we want. So startups have to focus on that. Green buildings and certification programs stick to certain protocols in effluent management and effluent treatment. There are what Aquasure tried, for example, they've got about 10% forward in a game which is 90% ahead. So sensory systems and IoT, and then AI into the realm of sewage management is the tomorrow. As we see it, it's already started happening elsewhere in the world, and it is high time that we shed the thoughts that sensors don't work. We have certain stupid ideas that sensors don't work. Mechanical systems are unreliable. We may have power cuts. I hear all this, like last 30 years I've been hearing all this, that you should not have pumped sewage. Why? What happens if there is no power? Come on, we are living in an era where we have assured power. Otherwise we got backup power. What happens is a sensor fails. Yes, that is a possibility, replace it. So there are sensor failure alarms available. So technology is something which is at your doorstep. These technologies that we are discussing today in this room about TDS meter and pH meter are available 50 years ago. We are not talking about rocket science. We are talking about systems which are there 50 years ago. So what we have to do is integrate them possibly in a manner that we bring about a solution which is hitherto unknown and which creates a direct impact on us, because that's what we are waiting for. The general public at large is not going to do research. They're not going to bring about any kind of change in their lifestyle. 95% of the people continue to live the mornings and nights every day same. So the 5% who make a difference are sitting in this room. So these are the people who will probably bring about the change, figure out how to solve small problems. So eco-restoration is a huge domain, and green building certification gives out the opportunity to make products, make systems, make technologies which are integrated with AI, and the world is changing faster than we can think. So we have to catch up somewhere. That's what I think.
Taking up that thoughts, Professor Shubha, considering your vast experience in the area of sustainable water management, can you please point out some of the innovation practices or the recent trends? Maybe in the research line also it is good, what innovation thinkers can focus on to develop something onto sustainable water management.
Actually, what he says that there is always key to sustainability, and the term sustainability is really a vague one. So whoever talk about sustainability, my perception or my vision on sustainability may not be the same as other, and may not be the same. So if I talk about sustainable water management or sustainable material or sustainable method, then first thing is that I have to define in my perspective what is sustainable. Suppose in the case of sustainable water management, we have to say that it is all depends upon natural resources. So natural resources is the one, and we should require technology for that. We can manage it in the real sense. And whatever technology is available, it should be affordable and adaptable to the people or whoever the beneficiary, and it must be backed up with institution and economics. So it is something like a chain, and if one of the shackle break, the entire chain will be collapsed. So there comes the vision it starts with. And of course, if you look upon the different trends that comes, as sir suggested, there is a digital aspects now we all are looking upon digital water management. That is, there is IoT, it goes to the machine learning and then to the artificial intelligence. So whatever development it comes, now we are always experiencing the flash floods, just like not with the seasons. So maybe if you have we connected with IoT and we can data can be collected from across. If you are to enter the headquarters of wherever it is, we can collect all the data from different aspects. If we talk about water management, how the fluctuations takes place from the dam, the level, and then if you connect it with the artificial intelligence, then they can simply operate it just like the robotic laundry work they do. Like we can have the gate management of what gates, the spillway gates, when to open, or how it can be monitored likewise. So that's a very good idea. And similar is the case with wastewater or water purification. We can go for different methods, that is advanced filtration likewise. So it comes, or desalination of water, that's again the scarcity of water. If you club with desalination with wave power or with the wind power, you can have the process. So many trends is available with the younger generation can look upon to bring with the startup aspects. So that is it.
Yeah, do you want to add something on that? And in terms of IRM's perspective, as you said about anything and everything on sanitation is all about the government policies and government interventions. So can you share some of the experience in implementing that kind of social enterprising projects?
Yeah, we started in 2008. We started designing this electronic toilet system. We thought it will solve the problems, but after some 8-10 years, we realized that it will not solve many of the issues in the public sanitation space. We had instances where government bought our systems. They paid us back after 1,500 days. We designed the system initially, and then we took 100 people. We selected 100 intellectual mindset kind of people from Kerala. It was from Sugathakumari teacher to KJ Yeshdas to many scientists and all. We made them visit our toilet, and we asked them, what do you feel? How do you feel about the system? And we got so many comments. Someone said it is closed, and someone said you need more protection, and many technical design aspects, everything we got. We started implementing it. Government will show you a space, then there won't be any electricity, then there won't be any sewage connection, there is no water supply. So eventually we are seeing toilets sitting, idling there, without any usage. When you find all these three connections, people may not come there, because the public utility connections is a bigger problem in the ground. Then what happened in 2012, we applied to the Bill and Melinda Gates Foundation. We got a grant. So far, we received around 22 crore grant from Bill and Melinda Gates Foundation, and we started developing so many components. And now we are in a position where we can set the toilet as a box. Where it will recycle 80% of its water, it will power from its solar, and it's a kind of an off-grid box we design. Then again, we realized in Bangalore, for the instances, Bangalore required 15,000 toilets to cater to their floating population, and government obviously cannot buy, and government cannot obviously maintain all these things. Then we started thinking about how we can make it a sustainable business model. Then we started adding shops to the toilet. We went to government and tell them, see, give us a 500 square feet of space. We will set up a toilet and shop together. It will be managed by a self-help group. Then we started talking to companies like Amul, Nestle, Unilever. Those kind of companies came in, and they were running the shops. Then we established we call it as micro enterprise for sanitation, addressing the challenges of you will have a sustainable hygienic toilet system, plus somebody is getting a job. So we have seen in 3,000 urban cities India we have. So if you propagate this model, thousands of employment can be generated. But the problem with the government system is, as I have seen in the morning session also, because the standards, the policies, and many other, the so fragmented nature of our system, it's very difficult to push to a government system where still an innovative product requires 3 quotation. The Wash Institute product, we are doing the manufacturing of it. It's a beautiful solution, and we also made some arrangement for, along with the support of Brilliant Institute, Goa, we made some sludge processing system also. One municipality in Kerala, they called it 4 times, and nobody applied. Only one agency applied. And 5th time, I think for the 4th time, government doesn't require 3 party. They just need 1 party. And finally we got selected. And interestingly, that product got certified by so many agencies. It was certified by RTA, it was under the Duke certification program, again it was certified under the Birla Institute, then again Wash Ministry approved, then the Ministry of Mahwa approved. So and finally this agency, this municipality selected us, and they said we will pay you only 50%. Then you prove, then we will pay you the money after some 1,000 days. So we decided we want to do a pilot. Then we took an order. Now then they set up 2 committees in government level. The 2 committees evaluated, and finally it is coming back to IIT Palakkad for another round of review. So it's the 5th time this is coming in. And secondly, okay, we decide that is our fate. We are working with the government and we want to work with the municipalities. So we decided we will go for grey water. We did a survey in Karakutam, Trivandrum, and we have seen one hotel is producing some 10,000 liters of grey water per day. And we have taken 10 hotels, they all together said, see, we will give you any letter you want. We don't have the space to set up the processing system. Then you do some mobile-based treatment for us. Then we suggested we come up with a mobile-based solution, and then the government come in. Government said, see, no, that's not possible. The law says you should have a system permanent there, and it's not possible. And we have seen some of those hotels are leaking water to the newly constructed highway. The newly constructed highway under, they put up pipes and they are sending the water there. So you decide to work with the municipality, you need to face all these problems. Then you go to the private sector again. These things of regulations and policies will come in. That's the system. But no way out. If you want to make some change, if you want to become a successful company or entrepreneur, or we need to work on it and work proving some solutions, like in the micro enterprises for toilet and shop model we did. Those kind of innovative models we should come up. That's it.
Since you said about the Gates Foundation focus on the indigenization of the technologies also, and since Hiram is also very much into that process, what are the key considerations when you are choosing a technology from overseas and doing it indigenization in the Indian prevalence? So what are the key considerations at a startup point of view they want to look for taking up a technology from abroad?
Big scope. We have taken 3 technologies. One is from Caltech University for converting 1,000 liter per day. It's an electrochemical reactor that's in display in Coimbatore for the last 3 years. And second was another technology, a containerized solution from University of South Florida. So all those technologies came with foreign components, a lot of costly components, and companies from US and Europe were supporting it. And we have seen tremendous reduction of cost. Because of the frugality of the Indian ecosystem we are working at present. So the cost, we could cut down the cost at least the system was costing around 50 lakh rupees with their this thing, and we could make it in 10 lakhs. So that's a kind of frugality of the system right now we have in India that is so dynamic, so supportive. And if any of the startup decides, without reinventing all the wooden wheel again and again, getting into these kind of markets and getting a technology and helping them to Indianize it will work. Last week, we are now setting up, just like GSEOE, we are now setting up one small showcase park in Masdar City, Abu Dhabi. So there we were talking, we were pitching our agriculture solutions. We have a small division working in agriculture to an Israeli consultant. We were so afraid, how can you go and talk to an Israeli company about agriculture? They are very good. It's like selling butterscotch to Eskimos. Very, very, very difficult. So, but finally we got the contract. We got the contract because of the frugality of the cost effectiveness, frugality and agility of the system. Now India is showcasing. That's so promising. That's a very big space.
Yeah, for all these processes, that including effluent treatment plant, STPs and all, we need trained professionals to operate, maintain and everything. So being an academic perspective, so what are the key points that we want to take in consideration for upskilling these professionals? Either it may be a design engineer or an MEP professional or a person who is very new to this field, what are the key considerations that we want to focus on upskilling?
Actually, about the STP, if I talk about, recently I have visited the 2 plants, one in Wellington Island and Elankulam for a BTech project students. And what I find is like most of the people is unaware of what the process of STP is. What I found is that they have doing the MBBR technology, the latest technology they are adopting. And finally the treated water, there is no system of collecting the treated water, so they are just simply having it to be disposed. So what I always feel is like we have tanker lorries to supply drinking water. So why can't we think about having this grey water collected and distributing to where it is required? So the effluent is the effect of what we produce it from the drinking water aspects itself, because we are making it waste, then sending it to STPs and likewise. So I think we have to think upon different aspects, like we have to motivate, do them, and then make some proto models, and then I encourage to do more research upon having small portable STP, so that maybe household itself or community based can be done instead of having a large STP volume to be collected and doing it, because in cities normally have more affluence. In the rural area there can be enough space. So all those things has to be looked upon, how it can be made smaller and do it in a community based outlook.
What is your intake about these upskilling programs where the focus should be for the MEP professionals or plumbing professionals should be?
In the MEP professionals domain comes in once the process of collection, conveyance and treatment happens. So each of these 3 streams being specialty streams by themselves. For example, design of toilets is it's a specialty field, and then we are yet to overcome the challenge of being able to make toilets that don't leak after 5 years. So in 2023 we are discussing, because we also have this consulting division for maintenance of existing projects. So we get flooded with inquiries about leaking toilets even now. So that's one area where upskilling is required. Now upskilling is, for example, you look at the Australian schools for plumbing or the American schools for plumbing, and the British schools. What differentiates us from them is the respect that is given to a plumber in Europe or in the US is hardly found for a plumber in our house. I don't think you will give him a sofa to sit in your house. Chances are 0. You will probably ask him to go and enter through the back door instead of coming through the front door. So it is the lack of respect for the work that they do and the lack of dignity of labor that affects some of the critical tasks. Not only plumbing, I can tell you 1,000 other things. But per se, when I talk about plumbing, STP operators, when we find it, see, I have designed STPs from 5 MLD, 2 MLD, 1 MLD, down to 10 KLD. So more than 400, 500 STPs I have designed. So where we face the challenge is getting people to operate it. What happens is, once I was interviewing one of the guys who was about to leave the operator's company. I said, "Why are you leaving?" In Malayalam he said, "Sir, എൻ്റെ കല്യാണമാണ്, എൻ്റെ ഭാര്യ വീട്ടുകാർ വന്നിരുന്നു, അപ്പോൾ എന്നോട് എന്താ ചെയ്യുന്നതെന്ന് ചോദിച്ചു. അപ്പം ഞാൻ STP ഓപ്പറേറ്ററാണെന്ന് പറഞ്ഞപ്പോൾ അവർ പോയി. സോ ആ പെൺകുട്ടിയുടെ അച്ഛനും അമ്മമാർ എന്നെ കല്യാണം കഴിപ്പിക്കാനായിട്ട് അവർക്ക് താല്പര്യമില്ല. It's a stupid reason. So I said, you are manning one of the biggest STPs in Kerala. At that time, Lulu Mall, which we designed, was in the private sector, one of the biggest STPs. Hey, you are working with no. So the stigma that is associated with people managing. I was hearing the second panel discussion, which was talking about the sanitation workers. I think there is a lot of misguided information there. That's not the reality. The reality is you and I will not allow a plumber to come into your house and sit in your sofa. Let us be very honest about it. You and I will not allow your electrician who has come to repair your bulb to come and sit in the front living room sofa. You will not. You will not offer him tea. So let's understand the problem is within us. Let's not try to find out solutions outside. We have to change our perspective about how we treat people. So why plumbing systems don't work, you don't treat the plumber properly. Why electrical systems don't work, you don't treat the electrician properly. So let's treat people properly and systems will start working. So same with STPs. I can guarantee you, I was having a discussion the other day with the Pollution Control Board here. 95% of the STPs in Cochin don't work. What she said was, if I start giving notices, I will have to start a department of 100 people just to start keep issuing notices. And there's more of work. So let's understand, catch the problem where it is. The problem is, we have to learn to respect people for the job they do. So I think upskilling is trying to educate somebody to learn a new skill, but what the society has to do in return is respect that person for that skill that he has acquired. Now engineers are treated like dogs. Engineers are treated like dogs. Let me be very blunt about it, because that's how they are. They are doing Swiggy, they are doing Zomato. Why? They are all upskilled people. They have the knowledge of mathematics and science and physics and chemistry, which others, probably 85% of the population, doesn't have. But when they are used to do delivery boy jobs, let's understand where the problem is. It is not with the people, it's not with the boys, it's not with the girls who are coming out of colleges, it's with us, the way we treat them. So upskilling has to be balanced with social outlook, and one of the biggest programs that the government, if somebody listens, is to give respect to people who are in the professional line, especially we were talking about longevity of the people in the sanitation industry. I think somebody was talking about, I have seen people who are cleaning manholes which are stuck with full with sewage. This guy takes off all his dress and without hesitation he goes into the manhole, which is filled with smelly sewage. This is respectable. I cannot do it. You cannot do it. So he's doing something which we cannot even think of. That's where society has to transform. I think that transformation, if somebody can do as a startup, do it. Because educating the society is the biggest challenge we are facing right now. We think all of us are educated. I don't think so. We cannot respect the people right next to us, the people who are helping us. We don't respect them. So upskilling has to be balanced with outlook. Social outlook changes. In US, you pay $250. $250 I pay my plumber. In Australia, I go, he comes in a car. Okay, I remove my car and allow his car to park because he's more respectable. And you get $300 out of your pocket and pay him happily, and he enjoys the job and he goes. Can you imagine doing that for your plumber here? You cannot. That's a change.
Yes, very much you said about that true fact that the dignity of the sanitation workers has to be improved. But the societal thing point, I don't know how to work with that aspect. Maybe Praveen sir has said about this Shuchita Karmacharis. By just changing the name, it will not make any cost, but by increasing their economy, livelihood, that has to be worked with technological interventions. As some of the points you said about the falling of the technologies from the hackathon stage to its implementation stage. So I'd like to ask Mr. Vinod, so during your pitch process or technological upgradation process, so what are the key critical factors that you considered to make the system, make the innovation process viable and to reach the market in a better way so that the technology can be revenue generating also? So can you throw some light on aspects for the sake of startups?
In fact, that's a very specific Kerala-related problem also. When you are starting a company from Kerala, you are a private limited company. You have the name as a private limited company, and you are going to work with government. And acceptance for startup boom was not there when we started. The acceptance was difficult. So then there is a way of making your ball or making your decorate your flower. That is the flower vase. That is how startup should think. First, what we did, we have a company. Then we started approaching Trivandrum Engineering College, for example, asked them for a support. Then they are given a consultancy. Then we paid Indian Institute of Science a 10 lakh rupees just to study the wind resistance of the toilet. It was not required. It was not required. We know our solution will withstand any air. They did a study. Then we got a stamping. IISc certified it. Then we went after the CII, ASSOCHAM and all those kind of organizations. So adding frills to what you are doing, how you are decorating, the flower vase you have. Then the gates came in. Then you are become the first company from India that is getting supported, and you met Bill Gates, and that credit we added. After Gates, some 15 universities started working with us. Now if we go, and then we started applying for so many awards. Some of the awards were not so good, but finally we got award from Prime Minister of India. Bill Gates came and visited our toilet. He entered in the toilet, and finally we made a ball. That ball, if somebody from outside will not see you as a bourgeois private company, you are a well decorated ball you have to bowl. You have all the 15, 16 foreign universities working with us. When we go and present to government and we tell them, see, we are this company, we got this much awards, we got this much tie-ups, we are working with Caltech. Last week I was there. That kind of setting up is required for a private, that is for the positioning side of it. But on the solution front, what we realized after 7-8 years, that you cannot simply work on depending on a single client. So your clientele and the model you work on, for startup, our experience is not about technology. As sir suggested, it's all there. Whatever technology you want, it's all there across the globe. You can just consolidate it and make it. But it's all about positioning and modeling. How you are modeling it. So you have, now we are working on a position like, see, 5,000 toilets with 5,000 shops attached to it. I'll go and talk to Amazon. I'll tell them, see, you have a toilet in Subhash Park, you have one in MG Road, I have one in Museum. If you want to tie up with me, you tie up. So that kind of situation, that the modeling aspect is very, very important in this sector. And this sector is very new. It is sunshine or sunrise or whatever. So those kind of modeling is required for startups. So when we are making a product, though somebody is saying that this is not good, not suitable, or it is there is already somebody is there, but you will evolve. When you start working on, don't get disheartened. You will evolve. Finally, if you are so passionate about bringing some impact or some solution in that, definitely you will reach that point. But the positioning side of it, one side, and then the solution side of it, and you will become the sovereign standpoint where you reach. Like, I don't need anybody, but I can withstand whatever the market think. So the thinking should be in that line. Normally in all our startup ecosystem, what we see, we start something, and then they have to learn us their own. So even government cannot do their. It's our call. It's our job.
Ma'am, in an academician perspective, what is your advice for the innovation thinkers or young brains that is thinking some out-of-the-box thoughts about sanitation drives or new ideas on this domain? How they can pitch effectively, how they can think of in terms of water management aspect as well?
Actually, there are so many. Now there is just like what do you think about nanotechnology aspect? So nanomaterial. So I was just thinking about the effluent that is being discharged from hostels or hotels to the things. So why can't we think about some innovative material through which the pipelines is having this screening, all these process such that the effluent is discharged safely to the standard to the drains? Because we cannot even because we have I born and brought up in Cochin, in the city itself, Ernakulam North, and that is what I experienced from my childhood to this. The population, drastic migrated population is here. A lot of hotels and so many shops have come across MG Road. It's just like Mumbai is some 10 to 15 years back. We cannot say that no drains to be connected with the hotels or all things. So think upon some innovative material in which in the pipeline itself it will have some gratings and so many things such that it will have some filtration of microplastics or some pollutants and discharge safely to the standards. That is one aspect. And secondly, we can have some algae or bacterial treatment processes for the effluents that also they can think upon. So many factors, something like, because now the people cannot think upon having huge structures for the effluent treatment, or they want, and also nothing should be free. So I was just thinking upon the toilet, that if we have provided in some places where that it's public, which have all stakeholders come across, and if they could experience, maybe a few of them can adapt the technology. That is the most easiest thing, which then convincing, I'm not sorry, that convincing the government to make it implemented. So the private stakeholders also can use a few of those. So likewise, we have to think, we have to change our perception, just like sir was saying that a plumber or electrician should be treated as a white collar job. So I think so many startups can be from the new generation that come for the effluent treatment, like adapting the new technologies.
In the domain of wastewater management, like ma'am was saying, there is a large segment which there is a large possibility which remains still unexplored, is the use of protozoa, unicellular organisms in wastewater management. I think that is one segment which probably nobody has looked at, because it's the simplest method of wastewater management, and probably that's something which IITs can very easily do. There is a lot of research issue in that. So my teacher in college, incidentally, I was helping her with her PhD in this. She's done a proto on this in Trivandrum. So that's one aspect. And then in wastewater management and conveyance, like ma'am was saying, we have to accept that, conveyance is the direct cause of 70% of pathogen in the environment in cities. 70%, because you have manholes at every 30 meters, at every 20 meters. Now, if it is single user effluent, the effluent is defined in parameters, and the biochemistry is, I can predict the biochemistry of the effluent. But when it is 100 people or when it is 1,000 people, the biochemistry totally changes. And if I am adding restaurants and hotels into this, then the COD levels and stuff like that, those go for S6. So we are looking at different values now. So therefore, public management of conveyance systems and manholes is a big issue, and we have to understand, actually there is a study required to understand the impact of manholes on public health. Because you're walking on that in footpaths. What goes underneath, we close our noses like this. But what is that? So we have to understand, we closed our nose for a moment, but there are people who are sitting on that, there are children who are walking. What is the impact of that? So the gases that are present there, the microbes and pathogens that are laid in the environment due to the sewage line below, due to the open manhole below. So that's something which nobody talks about. We're talking about wastewater management, that's a fact. But conveyance is the biggest challenge today as I see it.
Thinking about the implementation strategy, as nowadays everything is relied on the circular economy. So about the implementation of such smaller projects or effluent treatment modalities, what is the biggest challenge that one, as a design engineer or an implementation person, so that you are thinking of a challenge for implementing and making a revenue from that?
Excellent question, because this is one, when we were asked to redesign the sewage treatment plant for Lulu Mall failed. Okay, it was an under-designed system, and it was designed for like 460 KLD, and we were called upon to find out. So I did a 6-month analysis on the flow characteristics. So earlier I thought it was just a boom because there was a new mall which is opened in Cochin, and all the entire country is coming and visiting the mall. Every day I got 150,000 footfalls. So even the owner said, Ashok Bhai said, it will come down after 6 months. I said, it's not going to come down. So let's plan ahead. Let's plan for 1.5. First challenge, I don't have land. He said land cost at that time 55 lakhs, 60 lakhs percent, I cannot give you land. So I said, okay, fine. So we built it inside the basement of the multi-level car park. So you cannot see the STB. Then the second challenge he said, I don't have money. I've already invested once, so you are asking me to invest again. I said, okay, I'll return this money. You invest it, I'll give you a mechanism by which you return it. Okay, fine. So then we designed a system wherein the grease was separated, because the grease separators which are readily available, like there are several imported brands which are available, we have to throw all of them out. And we had a centralized grease separation system. And then the wastewater generated, we completely offset it into the chill water system, cooling tower, makeup water and all that. And the entire irrigation system. Then we started the concept of selling grey water. Where, because for curing water, for example, if I achieve a certain standards, I have 1 million liters of water, out of which I'm generating like 800,000 of treated wastewater every day. I cannot use all that. I can use probably 300,000, 400,000 maximum. Remaining has to go somewhere. So that can be sold per liter. So we entered the modality, the commercial modality that I entered with the contractor was, you do whatever. Treatment system is your choice. I buy treated water from you at 4 rupees a liter. I'll buy from you. That's your AMC. And buying water means you have to satisfy PCV norms and my norms. Because my norms are stricter than PCV because I have to sell it to somebody. I am selling it to him probably at 10 rupees or 8 rupees a liter. Anyway, he is buying from Kerala Water Authority at 140 rupees a KL. So then he said, you buy from me, 90 rupees, 80 rupees. So there is an economy that revolves around this. People don't look at it. All the grease that is collected, that goes into soap manufacturing and into several other aspects which, several other industries depend on that oil. So everything that is classified as waste has got some use somewhere. So it is, I always call waste as a resource in motion. It is a resource in motion means it has completed one job, it is going to its next job now. So, all the trees, leaves that fall in the forest where resources at time, they fall down, they become humus. Same way, waste can also be used. And this is one aspect of economy which needs to be looked at. Every STP is a revenue generation opportunity. Same is the case with solid waste management. We didn't touch upon solid waste, but solid waste, ours is about liquid waste, yeah. So solid waste management, same way. It is liquid gold, solid gold. The other one is liquid gold. So it's a way of looking at it.
So Vinod, your intake about this closing the loop and making the bio-circular economy.
Yeah, the 2-3 models after the years of effort in setting up and selling toilets to government, we realized that, see, this will not work. So the toilet and shop model is where we said no, we will not sell cola, Pepsi there, but trying to bring in some good food shop, health kiosks attached to the toilets. So creating employment, 3 employment per unit, 1 toilet and shop, 3 people from the desired segment is engaged. So bringing in CSR funding, when you go and tell a company that spends CSR fund for setting up a toilet, they are not interested. But if you are telling them, see, 10 years you can have the advertisement, you are giving employment to 3 people, then it will sustain for next 10 years, they will come in. That is a practice we do in that space. And secondly, then we also devised a model where 50 toilets as on rental, plus a back-end vehicle. That back-end vehicle will go and give waste and suck waste in the evening, and it will process. 1 toilet, 50 users per day into 5 rupees will make the model viable. So that model is now getting practiced in Bangalore. So that is where government is not there. We are offering everything. So that is the second one. And we also did a similar exercise in the solid waste side. So we are taking waste. From the collection itself, it is viable. From hotels, we are taking 15 in Kochi also. Some franchises, like chicken making franchises, they pay around 1 lakh rupees per month for collecting, for sending their waste out. So we did a small study in our place in Trivandrum, Kavadiyar, where we have seen 25 hotels together spending around 1.5 lakh rupees per month for just taking the waste away, saying that it is for the pigs. And now Government of India realized this will not work. I think there is a legislation is coming in that there is no such big pig numbers is available in the country. They are saying it should be go for pyrolysis or biomethanization. So those kind of circular practices, engaging people for maintaining this and making their project and trying to see this is a revenue making and a ATM, a toilet you fix it up, it's an ATM for them, for us. So that's the kind of a model we are working in. But it has got all the practices, best practices in the sustainability, whatever, the space we can do, we are practicing it right now.
So as a final point, asking with Professor Shubha, what is the critical advices as an academician or a teacher that you can give to the innovation minds, especially the students, how to focus with such kind of an innovation practices, not necessarily with the sanitation, but anything on this domain that supports the social welfare, social enterprise, or ecologically friendly innovations. What is the good advice that you can give to the students?
Yeah, we must say about the best management practices, because we the humans who is taking all the resources from the nature, and what we do is that we will make the products out of it and then we just discard as waste. So that should not be the case. As Sir was pointing out, like waste is always energy and it is the wealth. So it can be either liquid or solid that we produce. So what I think is like whatever we consume from the nature, that we have to give back as a new thing by any, just like peace we say, prosperity, people, and everything is there. So whatever we take, we have to give back as some product which does not harmful to the nature. So then only we can keep everything that is sustainable for the future or preserve for the future.
Wonderful. With that thoughts, I would like to conclude, and before that, would like to take any questions from the audience, please.
Good evening, sir. Good evening, panel. Actually, Ganesh sir actually answered the question which I had raised in the morning session, how we can make this economically viable, and you gave a live example about the Lulu. But I have a small doubt regarding the same thing. That is, you can implement anything into a new project basically, but how can we implement it into a current existing infrastructure, which is, let's say, MG Road? Take an example. I have a live experience where I was a subcontractor for Cochin Water Metro. So we had to do a tie-in into the STP near the MG Road. And unfortunately, nobody even knew where the line was. And what happened was they paved the footpath over the manhole. We couldn't identify and we had to take over the footpath. And then we found the manhole, which is 2 meters deep. And they have no method statements, or they have no idea where the line is going. So that is one issue which I want to raise. Like, how would you suggest to implement into an existing cluttered situation like this? That is number one. And number two, when it comes to the financing, primarily with my experience, what I've seen is everybody wants an NOC. They don't want an STP. That is the only reason why people are putting STP here, just for namesake. So even I raised an issue for the subsidization of the STPs. Like, if government can bring up something like this into a scheme or a collection where, the owners find it possible that they can make the revenue out of it, or they don't want to incur extra costs. How can you advise on those 2 points basically, existing facility and how the small scale people can benefit from this?
I think your discovery of manholes in the sewage system in Ernakulam is commendable, because there are several people who are still trying to find out where the manholes are. So if you were able to find out, congratulations. The department itself is struggling with it. The problem is the engineering is forgotten. the engineering is forgotten, and short term, myopic is a golden word. Short term means you cannot have it shorter than that. Immediate gratification is sometimes the requirement of the day. That is why engineering is forgotten. That is why you will see these manholes were laid probably long time back, and you're not going to find any as-built drawings, no method statement, nothing you're going to find. So you discovered a manhole, great. There are several people who are still trying to figure out where the nearest manhole is. So second thing is existing ecosystem, trying to generate revenue out of it. If anything to do with Kerala Water Authority or the LSGD or the government, please take a lottery ticket, because that's not going to work. For the simple thing is, I have done this in 2009, and there I found out what is going to happen. So that is a lottery ticket. The potential is unrealized. The sad part is, the potential is unrealized. The amount of wastewater, he was just mentioning 25 lakhs per month for collecting waste from one city, one portion. Now, you look at Cochin, which is an equal project like Trivandrum, you have similar lines of numbers. The fun is, our politicians, our decision makers, our bureaucracy doesn't need to understand these numbers. So I'm sorry to say, this is a very difficult question to answer. The economy is very much live. It is still there. It works every day. It's a 100 crore plus revenue model. 100 crore plus. Now I'll put the challenge to IIT Palakkad. If IIT is to lead, suddenly all these bureaucrats and politicians will come down. You and I will be asked to stand outside in a queue. Your experience. But if IIT Palakkad says, okay, this is our pilot project, we are going to do it, we are going to discover all the manholes, we are going to map it, we are going to take the most advanced of radio sensing devices or thermal sensing devices and give you the map of Cochin's sewage system. That's a project which nobody else can do, and Kerala Water Authority does not want to do. Whatever politics we have, let us be very clear about it. So, if IIT Palakkad says, let's do it as a pilot project for converting sewage into revenue, for converting solid waste into revenue, then it will work. As commoners, no, not possible. Potential minimum 100 crores per month, not year. Per month. Let me be very clear about it. That's the kind of wastewater we generate.
Is there any other questions from the audience? If not, we can conclude our deliberations by here, and with some take-home messages that eco-restoration is all about halting or minimizing the pollution that we have already caused to the environment by implementing the reducing or recycling or whatever our strategies that we want, and reviving the vegetation also. And novel innovative concepts and technological interventions are doesn't necessarily need of the hour for making that implemented in the ground, and to promote the restoration and the conservation practices that will form a loop and protect our environment from further damages that we have already created. I hope that the views and the concepts already put forward by the eminent panelists are thought-provoking, and we will take up that positive notes for further strengthening our processes for sharpening the innovative skills. With that, we would like to conclude and thank you once again for joining with us. Thank you.
Thank you, panel, for the informative session on various interventions already available in India and the possibilities available for startups entering this domain. The session has been an eye-opener for some of us as well. Now I would like to request Ms. Anuradha Shankar to give the memento to Dr. Sudha. Thank you, ma'am. Now I would like to invite Mr. Praveen to give away the memento to Mr. Sri Ganesh V. Nair. Thank you, sir. Now I would like to invite Dr. Praveen to give away the memento to Mr. Vinod Subramanian. Thank you, sir. We would like to have a short break for tea. Thank you.
I request Anuradha ma'am to distribute the participation certificate to the team Aquasure.
Okay, I just want to say a few words. Aquasure, good job. You have come up with an idea, but I think I've given you a small note. Work on those points and the points that the other panel also said, because idea is good till you make it work, right? And in order to make it work, you have to go through a whole lot of basic ground, secondary research, test out various things, find out what is really needed by the customer. Like, if you want to say that this is water for bathing, the parameters are different. Water for washing your vessels, parameters are different. Water to just water the garden or something, parameters are different. Make it drinking water, parameters are very, very different. So make sure what are the parameters required and what should you test, right? So please come.
Mr. Henwin Joy. Mr. Amal.
We have a Samastha program every quarter, so improve on it and come back, right?
Mr. Grinan Paul Raphael. Maria Shaju. Thank you, ma'am. Thank you, team Aquasure. I invite Mr. Rahul for vote of thanks.
Good evening, everyone. As we come to the conclusion of our third offline event of Prabhaav Innovation Grand Challenge, on behalf of the entire organizing team from Tekin and GSUE, I would like to thank each one of you gathered over here for making this event a success. I'm sure that the participants and innovators would be highly benefited from these deliberations and experience shared by today's speakers. It was a day well spent, as we are privileged and honored to have Dr. Venkateshapati IAS, Managing Director of Kerala Water Authority, as the chief guest and keynote speaker. We are highly obliged to have Dr. Praveena Gangadharan as the plenary speaker and share her thoughts and wisdom in today's event. Further, I would like to take this opportunity to thank all our panelists, including Mr. Ramachandran Pullat, Mr. Bijo K. Jong, Mr. Sakaria Joy, Mr. Rajaraju Kumar, Mr. Praveen K.S., Mr. Sarosh Kodandat, Mr. Srigesh Vinaya, Dr. Subha Vishnudas, and Mr. Vinod Subramaniam for joining us today and sharing their experiences. We extend our thanks to Dr. Sunitha K. Nair, Dr. Praveena Gangadharan, Dr. Praveen Govind as our moderator for the panel discussion. Then we would like to mark our heartfelt thanks to all our supporters and institution partners in this journey. Directors, staff members and students of our parent organization IIT Palakkad, which is the strong pillar of our support. We would like to thank the Office of PSA, Government of India for the directional support and as our facilitation partner. Thanks for our funding partners HDFC Bank and Bill and Melinda Gates Foundation. Thanks for our technology partners IAPMO India, ARM Scientific, Toilet Board Coalition for the knowledge shared and networking provided. Our sincere gratitude to all our incubatees, pool of mentors and ecosystem partners for the continued support for our innovation and incubation activities to keep us moving forward in the right direction. Thank you management and staff of Holiday for providing the ambience and nourishment to keep us in good spirits. Thank you all staff coordinated with us, including the photography team. Last but not the least, we thank all the participants and my colleagues at Tekin who joined us today and make this event fruitful. Thank you very much.